From ancient civilizations to the lost city of Z, we've got you covered at Brothers of the Serpent podcast.
Oh, wow. That's good.
Yeah, again.
Welcome back, ladies and gentlemen, boys and girls, angels and demons and monsters and serpents to Brothers of the Serpent podcast.
Heck
Coming
yes.
to you not live from the 10 by 10 by 10 tangent cube of science, nestled amongst the dusty bones of an ancient seabed high atop the Edwards Plateau.
Did you catch all that, Grand Watcher?
Tangent cube. Sadly, we do not have the Watcher with us today. He is very sick. I am still getting over being very sick.
Yeah, he has the space flu. It's
pretty
apparently
serious.
it's an epidemic. Up
Came
there
from
right
space. Yeah, that's right. It's like space plankton.
Now. Yeah, everybody up there has it. All 5 of them.
He may be joining us later on, but right now he is severely under the weather, so we are going to be trying to go it alone with no Watcher. So this show may veer off into unknown tangents. You just never know. And also, remember that since we're not being watched, some of our facts may be wrong.
Yeah.
We may be more wrong than we usually are.
That's right.
All right, so it's just I don't have to introduce the Watcher. We start out with space weather news from spaceweather.com. Solar wind buffets Earth. Earth is inside a stream of solar wind flowing from a southern hole in the sun's atmosphere. This is causing geomagnetic unrest, albeit not full-fledged storms, around the poles. Arctic sky watchers should remain alert for auroras on February 13th and 14th. And a snowstorm hits Hawaii on Monday. A historic winter storm pounded Hawaii with hurricane-force winds, massive waves, and snow in some unusual places. Maui was blanketed in snow at altitudes as low as 6,200 feet, the lowest snowfall since 1952. At the 10,023-foot summit of Maui's Haleakala volcano, or Haleakala volcano, many world-class telescopes were frozen solid.
It's going to be a song of ice and fire.
We were finally allowed to get into Haleakala National Park to get to the Haleakala Observatory, reports Rob Rakowski, who photographed the scene. About a foot of snow fell, creating black ice that was a danger to vehicles. When we arrived today, we saw much ice attached to buildings, observatories, and fences. The Haleakala Observatory was Hawaii's first astronomical research and development facility, managed by the University of Hawaii's Institute for Astronomy. The summit is home to the Atlas Asteroid Impact Early Warning System, the Air Force's Maui Space Surveillance Complex, the Pan-STARRS Asteroid and Comet Survey Telescope, and still under construction, the Daniel K. Inouye Solar Telescope, the most powerful solar telescope in the world, capable of studying the sun's surface, corona, and magnetic fields in unprecedented detail. These and other telescopes on the summit may not thaw out until next week. The National Weather Service has issued a winter storm warning for Haleakala that does not expire until Friday. A mix of wintry weather is expected early Wednesday and then again on Thursday, making travel to Haleakala's summit extremely dangerous. Be careful. Snow in Hawaii.
Yeah. Snowing right into
The
a
frickin'
massive ball of
It's like getting snow on Floston Paradise. It just doesn't happen.
Should be filming Game of Thrones out there, I'm telling you.
Winter is coming. All right, so still in the vein of space weather news, we have NASA finds possible second impact crater under Greenland ice.
Yes.
A NASA glaciologist has discovered a possible second impact crater buried under more than a mile of ice in northwest Greenland. This follows the finding announced in November 2018 of a 19-mile wide crater beneath Hiawatha Glacier, the first meteorite impact crater ever discovered under Earth's ice sheets. Though the newly found impact sites in northwest Greenland are only 114 miles apart, at present they do not appear to have formed at the same time. If the second crater, which has a width of over 22 miles, is ultimately confirmed as a result of a meteorite impact, it will be the 22nd largest impact crater found on Earth. Think about that. It's 22 miles wide, 22nd largest impact crater. A little weird there. We've surveyed the Earth in many different ways from land, air, and space, and it's exciting that discoveries like these are still possible, says Joe McGregor, glaciologist with NASA's Goddard Space Flight Center in Greenbelt, Maryland, who participated in both findings. Before the discovery of the Hiawatha impact crater, scientists generally assumed that most evidence of past impacts in Greenland and Antarctica would have been wiped away by unrelenting erosion by the overlying ice. Following the finding of that first crater, McGregor checked topographic maps of the rock beneath Greenland's ice for signs of other craters. Using imagery of the ice surface from the moderate resolution imaging spectroradiometer. Wow, spectroradiometer. Okay.
Radiometer.
The moderate resolution imaging spectroradiometer instrument support NASA's Terra and Aqua satellites. He soon noticed a circular pattern some 114 miles to the southeast of Hiawatha. The same circular pattern also showed up in Arctic DEM, a high-resolution digital elevation model of the entire Arctic, derived from commercial satellite imagery. I began asking myself, is this another impact crater? Do the underlying data support that idea? McGregor said. Helping identify one large impact crater beneath the ice was already very exciting, but now it looked like there could be two of them. McGregor reported the discovery of this second possible crater in Geophysical Research Letters on February 11th. To confirm his suspicion about the possible presence of a second impact crater, McGregor studied the raw radar images that are used to map the topography of the bedrock beneath the ice, including those collected by NASA's Operation Ice Bridge. What he saw under the ice were several distinctive features of a complex impact crater, a flat, bowl-shaped depression in the bedrock that was surrounded by an elevated rim and centrally located peaks, which form when the crater floor equilibrates post-impact. Though the structure isn't as clearly circular as the Hiawatha crater, McGregor estimated the second crater's diameter at 22.7 miles. Measurements from Operation Ice Bridge also revealed a negative gravity anomaly over the area, which is characteristic of impact craters.
A negative gravity anomaly.
Like it's lower gravity, yeah.
That's weird.
Yeah.
Trying to figure that out, but I'll save that for later.
Trying to figure it out on the fly.
Yeah.
Let's
It's
see.
shoving
Shocked quartz.
stuff. It's pushing.
Shocked quartz blocks gravity.
Somehow the time-space compression is not. I don't know.
All right, what do you got? Let's have it. Let's start with Space Weather News. So that was from NASA.gov and spaceweather.com.
Yeah. This is Sky Weather News. Mystery booming sounds have been shaking houses and terrifying residents after flashes of light were spotted across America. This is from the sun.co.uk. Experts have been left baffled by a spate of seismic booms from Arizona to New York that appear to have gathered pace over the past week. The string of phenomena were first reported last Thursday morning when locals in 3 separate Tennessee counties reported hearing loud booming noises. Wow. On the same day, North Carolinians contacted police reporting unexplained loud blasts and booms that kept them awake at night.
Wow.
2 homeowners said the booms were so powerful that they briefly lost power as a result of the tremors. Mysterious Universe reported.
Lost power.
Yeah.
That's interesting.
Yeah, booms are definitely power suckers. Yeah. Mary Buck told The Sun Online, there was a loud, stupid header. There was a loud boom heard in Gum Spring, Virginia on Wednesday, February 7th, around 7 p.m. My neighbors and I heard it. We live close to Interstate 64, so we just assumed something happened, but there were no reported incidents. It sounded like an explosion. Could be related to other mysterious boom noises reported. Similarly, unexplained explosions have been reported happening in isolation over the past years, but rarely with this frequency. On Saturday, loud bangs were reported in Rhode Island, where Jeremy Braz's doorbell captured a video and audio of a loud noise over a 3-minute period. The whole house shook, he told turnto10.com. It woke my wife up, woke up all my children. The following night, an explosion was heard in New York, accompanied by a mysterious flash in the sky. What the heck was that boom or explosion in Park Slope, Brooklyn? Asked Matt Wasowski on Twitter. Another wrote, extremely loud boom in Brooklyn? WTF? Some speculated that the boom could have resulted from a manhole explosion, but the true origin... yeah. Manholes often explode. But the true origin is yet to be explained. These booms were followed by strange cannon-like sounds in Harahan and River Ridge in Louisiana, where they have also kept residents up at night. Residents say the sounds have been going on for for weeks, and nobody seems to know what causes them.
Wow.
While Philadelphians were rocked by a series of mystery booms a week ago and again on Tuesday. Mysterious Universe speculates that the phenomenon could be caused by cryoseisms. Cryoseisms.
Cryospasms is what I think.
It must be misspelled.
Yeah.
Cryoseisms. Cryoseisms. Or frost quakes, which could come about in extreme cold climates. Okay. Yeah.
Yeah. Sure.
Whatever the other word for
they
frost
also-
quakes is.
They are also known for frost quakes cause bright flashes in the sky.
Yeah,
It's
yeah.
totally legit.
Yeah, exactly. But the explanation doesn't wash in areas where temperatures don't typically plunge low enough for that to happen.
Yeah, like Louisiana.
Yeah. Could these anomalous sounds be sonic booms caused by undisclosed aircraft activity? The author asks.
Of course he does. That's the next scripter.
Any guess is as good as any at this point. No, they're not.
No, they're not.
So, yeah, so extremely active frequency of sky and flashes of light.
That's cool. Like that was all over the place.
Yeah.
Wow. And very recently. So
Yeah, that was reported on February 7th by thesun.co.uk, where we misspell things like colour
Kalur.
and neighbour.
All right. So most of you know that we are huge peer nerds at this podcast. If you look at our on the website where we have all the keywords, the most used one, the largest one says pyramid. We
That's
are
right.
like massive peer nerds. So most people that kind of look into this kind of stuff do know about the quote unquote like secret door in the Great Pyramid that was discovered up to one of the
The ventilation shafts.
right, the air shafts from the Queen's Chamber. But there's a much larger story around the discovery of that has a lot of other fascinating aspects, and that's what I want to go into. That's going to be the main topic of this podcast, basically. So I'm going to be reading from Rudolf Gantenbrink's website.
Can we call it Gantenbrink Store?
Yeah,
Is that what it's called?
Gantenbrink Store.
That's what it should be called.
That's what it should be called. So this is from cheops.org. That's where you can find his website. And these are what I'm going to be reading here are not articles. These are not popular articles. This is from his own. These are his own words about, and it basically goes through the whole project, what he was actually doing there, how he ended up getting into this, and what the findings were like. And there was a lot more stuff that he found besides the door. Okay. And it's not even clear that it is a door in the first place. So that's what we're going to be doing. So I'm going to go ahead and start with this because this whole saga is fascinating. So this is in Gantenbrink's own words. Okay. Early days. My interest in the pyramids of Egypt began in 1987. On my birthday that year, a friend gave me a book, The Seven Wonders of the World by Werner Eckschmidt. The last chapter deals with the only remaining wonder, the Cheops Pyramid on Egypt's Giza Plateau. So the seven wonders of the world, there's only one left, and that's the Great Pyramid. My engineer's curiosity was aroused because there seemed to be so many questions and so few answers. I couldn't get over the fact that we can fly to the moon and explore the depths of the oceans, but we can't answer so many basic technical questions about the most exhaustively studied historical monument of all time. The book contained references to the German Archaeological Institute, which is the GAI, and its director, Professor Dr. Rainer Stadelmann, to whom I soon wrote expressing my interest. At the same time, I began analyzing the pyramids as of 1989 by computer, looking for telltale signs, the fingerprints always left behind by the designer and builders of any large construction. In the early 90s, I began developing a computer-based study focusing on the knowledge of the ancient Egyptians and the means available to them to conduct their work on various monuments. Because of my interest in the technical aspects of archaeological issues, I have supported and initiated a number of projects and studies throughout the 90s, including the Siwa Oracle Temple Computer Survey, the Upuaut project, the ventilation of the Cheops Pyramid, and the dating of the Nazca geoglyphs in Peru. As a further private initiative, I set up the Upuaut Foundation, a specialized high-tech source for digital conservation and fieldwork improvements. In connection with those endeavors, I have secured the necessary funding and sponsoring for such projects from companies like Compaq, Gore, Port SCAP, Maurer and Wirtz, Autodesk, DataPath, LTG, Helios, and ABC Camtech, to all of whom I remain gratefully indebted. Above all, since my on-site investigation of CHEOPS ended in summer of 1993, I have continued to conduct extensive computer analyses of the data to further refine the equipment, especially the robotics, required to advance our exploration of the Great Pyramid, and to actively promote that exploration. I remain convinced that, given the opportunity, we will soon be able to solve the remaining mysteries of CHEOPS. Okay. Becoming active. In 1990, Professor Stadelman of the GAI made a visit to Munich, and I finally had an opportunity to show him my work. He seemed both surprised and impressed by how much my computer analysis could tell about the construction of the pyramids, about the possibilities of mathematical visualization, and the inherent potential of the high-tech approach. Professor Stadelman's reaction to my work encouraged me to make a trip to Cairo, which I finally did only 3 days before the outbreak of the Gulf War in 1991. My first visit to the Giza Plateau not only made me forget the geopolitical implications of the high-tech warfare soon raging not far away, it was to change my life. As I walked around the plateau, I was astonished by the fact that there were bits of evidence strewn everywhere, invaluable clues to how the pyramids had been constructed. I was struck by the wealth of evidence available to the eye of an engineer. I was moved by a feeling of encountering kindred spirits. Nothing otherworldly, mind you. These ancient Egyptians simply seemed to have taken an approach to their task which I felt very much at home with. But I was also shocked because the evidence I perceived was constantly being lost and destroyed, not just by the slow processes of gradual erosion, but swiftly, daily, right before my eyes, by the masses of tourists whose feet, guides, and camels were scattering and crushing a wealth of priceless clues and information. From that moment, I resolved to do something about it, to try to prevent the ongoing loss and to make a contribution to solving the riddles. This was also the first time I would encounter the hordes of mystics, spiritualists, and esoterics who conduct groups and services in and around the Cheops Pyramid. Later, such groups were to provide a permanent source of conflict as my work at the site proceeded. After my visit to Giza in 1991, I managed to meet up with Professor Stadelman at the offices of the GAI in Cairo. I suggested conducting an investigation of the so-called air shafts of Cheops. I was convinced that the shafts marked the first construction phase of the pyramid. They constitute basic elements of great importance. Put simply, a stone structure of such magnitude, built up in layers over a period of many years, is a sufficiently gargantuan undertaking to daunt any builder. But adding diagonal shafts through such a structure so complicates the task that it becomes a builder's nightmare. The builders must have ascribed great significance to the shafts, otherwise they never would have let themselves in for such a massive constructional headache. Throughout my investigations on site, I was never looking specifically for hidden chambers or treasure, as has often been alleged. I was simply determined to apply common sense and solid engineering data to solving the riddles presented by those shafts. What purpose did they originally serve? At the time of our discussion in Cairo, Professor Stadelman was not yet aware that modern technology can make such an investigation possible. As a result, he was immediately taken by the idea and proposed that we embark on a joint venture project. So I returned to Munich and began preparing a project definition, which I soon sent to the GAI. I suggested using a small robot to investigate the so-called air shafts. I included the initial design and drawings of the robot, as well as specifications of the overall logistics and team which would be necessary. Even at this early stage, I anticipated that the steeply inclined, which is 45 degrees, upper southern shaft might be relatively free of debris and thus easily negotiable, but that the upper northern shaft, much less steep, which is only at 32 degrees, might be badly clogged and thus that a larger clearing and cleaning operation could become necessary. I also began refining the robot design based on my observations in Giza and started building those parts of the robot which were essential to the task. While still in Cairo, Professor Stadelman and I had agreed on a sensible division of labor. I would handle the technical preparations of the project, and the GAI would secure all the necessary permits in Egypt. Throughout the latter half of 1990, I was surprised not to receive any response to my project proposal from Professor Stadelman. But during my next visit to Giza in January of 1992, he did arrange contact with the Giza Plateau Inspectorate, through which I was granted permission by Director Zahi Hawass to climb the pyramid accompanied by an inspector. My objective was to find the outlet of the upper southern shaft, which had been lost and forgotten since the early 19th century. Think about that. Like, it was found, you know, this happens a lot. Like, somebody finds it like Petrie or whatever, and then And then it just gets lost. They know it's
crazy.
there,
Like,
but no one freaking knows where it is.
That's how freaking big this thing is.
Yeah.
You can lose a shaft that's on the side outside.
Right. Yeah. They know it's there, just no one knows exactly where it is, what level, and all that kind of stuff.
It seems like one person could just systematically walk each level and find it.
They just hadn't. Yeah.
They just hadn't done it.
No one knew officially where it was. So
I thought people had tried for a while. Like people
had tried to find it, but it's so enormous. 14 acres is a lot of area of up and down area to explore, and you can't see what you need to see from below it.
Yeah.
You know? All right. So my objective was to find the outlet of the upper southern shaft, which had been lost and forgotten since the early 19th century, and to inspect the Caviglia tunnel at the bottom of the upper northern shaft. At last, the big day arrived. I was to climb Cheops for the first time. With the inspector, I ascended via the southwest corner of the pyramid. On the way up, I noticed that the stone was badly eroded, porous, and broken, but in many pieces it seemed to have been worn smooth. The explanation of this little puzzle was quite simple. This had always been the route of ascent favored by unauthorized climbers because the southwest corner of Cheops can be directly observed neither from the inspectorate nor the police station, both of which are located near the north corners of the pyramid. So this is the backside. Based on the extensive computer analysis I had made of Cheops, I was able to find what I was looking for on the first attempt, the lost outlet of the upper southern shaft. It was an auspicious beginning. So basically, just from his computer models, he knew about where it should be, and he went straight to that spot, and he was like, here it is.
Freaking engineers, gotta love them.
Yeah. Later, I also investigated the Caviglia tunnel at the lower end of the upper northern shaft and made photographs of sand deposits in the shaft, convincing me that because of the bends along its path upward, the shaft was twisted. Afterwards, I discussed these findings with Professor Stadelman, who was very excited. But it was also during this meeting that Professor Stadelman confided that he had had some headaches with our project. He said the Egyptian authorities had granted permission for the proposed project, but that he had inadvertently offered to include installation of a ventilation system in the upper shafts of the pyramid as part of the project. In other words, that was the deal. He couldn't just get permits to do this.
Right.
The deal was like you get this German engineer and his company and all these badass companies to install this stuff for free. And then we'll let you do what you want.
Yeah.
Not for free, but we don't get charged, right? We don't have to pay for it, basically. Right. So that they would have to foot the cost to install this ventilation project. So he said, I told him I did not see any great problems of including this in the project definition and offered to take care of planning and organizing such a system. I also proposed to find sponsors for the undertaking and secure the necessary materials and equipment. So he's like, no problem.
Like, yeah, straight to pyramids.
That's right. The Giza inspectorate provided me data they had collected over a 2-year period on the humidity and temperature levels within the pyramid and on the numbers of visitors to it. Elated with my discoveries and the prospects of a fascinating project, I returned to Germany. I immediately set to work developing and building the first, as yet unnamed, robot, based on the design submitted in my project proposal for exploration of the shafts. Based on my most recent findings in Giza, I refined the design and a number of construction elements, many of which were made of heavy-duty plastic. This model would turn out to be too tall to get through some of the shafts and simply not sturdy enough for the overall task of negotiating numerous obstacles while climbing at a sharp angle. To my chagrin and frustration, I later discovered that I had underestimated the difficulties of the undertaking. In my eagerness to keep costs to a minimum and get started as soon as possible, I neglected to conduct adequate trial runs on mock-ups of the shafts. As a result, I would later have my hopes dashed and my robot stalled. The first robot, which came to be known as the father of Upuaut, was relatively inexpensive as it incorporated a number of prefabricated parts. It was a fixed construction, basically unchangeable. Only after the initial attempts to negotiate Cheops' shafts went badly did I recognize the crucial importance of a highly specialized, totally customized, high-tech solution. But in the early spring of 1992, I was still unaware of the headaches to come. For our coming venture to clear debris from the upper outlets of the shafts, I bought the alpine climbing equipment we required. Professor Stadelman had cautioned against accidents, which might give critics an opportunity to claim that once again the curse of the pharaoh was at work. And the last thing we needed was more grist for the esoterics, or gris, however you say that. I also purchased surveying instruments to measure precisely the bending shaft sequence inside the Caviglia tunnel. As I succeeded in gaining the collaboration of the, Lufttechnische GmbH, to do the ventilation system calculations based on the data I had brought back with me from Giza. Through LTG, I also secured the support of the Helios Ventilator Company, which furnished the materials we needed. Finally, my preparations were concluded, and all of the material and equipment was sent via the German embassy to the GAI in Cairo. Okay. Let's see. Where am I at here? All right. So let me back up here. I got to navigate this website. So that was early days becoming active. Okay, the first 1990 campaign. All right. The first 1992 campaign began in March and lasted 2 weeks. The GAI provided me their photogrammeter, Ulrich Kapp, for the full period and for several days each, 2 different Egyptian workers, Mohammed and Abdel Nasser, as assistants. Because the ventilation equipment was not yet ready, we embarked on the original plan, video inspection of the shafts. At this time, the Egyptians were still reluctant to close the pyramid for our investigation, so we could not work on the outlets of the shafts. In particular, the outlet of the upper northern shaft lies 80 meters directly above the tourist entrance to Cheops, and the risk of falling stones was simply too great.
Yeah.
But it was possible to close off the corridor leading to the Queen's Chamber, allowing us to work in relative peace there where the 2 lower shafts begin. So this is what's interesting here.
Poor Graham Hancock is like showing up.
Graham Hancock goes in there and finds off his clothes off. He's like, what the? It's hilarious how these 2 things intertwine like that. You read in his book that he's like, the thing's closed off, and he's like, ah!
He's all mad, yeah.
Yeah, he writes it in his book how he's mad that he can't get in there. And then he finds out later that it was because Gantenbrink was down there.
That's freaking awesome.
Okay. Excuse me. It was possible to close off the corridor leading to the Queen's Chamber, allowing us to work in relative peace there where the 2 lower shafts begin. Almost immediately, however, I discovered that the shaft showed evidence of serious settling due to the thrust of the chamber roof beams. The settling of the southern Queen's shaft amounted to 4 centimeters, leaving a passage space of about 16.5 centimeters, but unfortunately my robot had a minimum height of 17 centimeters, too tall to get through by a grand total of 0.5 cm. After all my careful calculations and enormous preparatory work and expense, an immensely frustrating revelation. Determined not to be stalled before I'd even gotten started, I tried to squeeze the robot through the narrows, and it got stuck. In order to extract it, I had no choice but to break off several parts, adding pain to vexation. No! Go, my robot! Nonetheless, we did manage to push the robot and its TV camera a distance of just over 12 meters into both shafts. Egyptologists had always maintained that the lower shafts were only token or insinuated constructions. In this conventional view, these shafts were probably quite short, perhaps only 3 to 4 meters long.
And they were, of course, totally right. All that time. Until they were proven wrong.
That's right. And they simply implied a passageway for the escape of the pharaoh's soul. Thus went this theory that there had been no reason for the pyramid builders to complete them. So despite my bitter disappointment at not being able to proceed farther, we had already succeeded in blasting some serious holes in that theory.
What a cruel joke. Oh, sure, Pharaoh. Yeah, we're putting the shafts for your soul.
Yeah, don't worry, man.
And then they just end. That's like...
Yeah. In the northern shaft, we could even see the end of a long rod extending up farther into the shaft. So there are pictures on his website. They're very small, but I will put them in the show notes. There it shows the settling, so you can see the shift, and then there's the end of Dixon's rod.
Yeah. I'm sorry. This is... I just have to point this out. Like, we've talked about this before, but it's like... for lack of a better word, the bigotry of this idea that the Egyptologist model has about these people and this total BS that they believed, right?
Right.
Oh yeah, the soul needed to go up this. So it's just symbolic. So then they just end the shafts,
right?
Because the soul can travel through all that solid stone, but they put shafts in there just because they believe some stupid superstitious.
Yeah,
it's just.
Yeah,
just makes them sound like retards,
right?
You know?
But then they'll turn around and tell you that it was incredibly important to them to do some ridiculously precise thing ceremoniously because it's ceremonial,
right?
But they'll just end the shafts after 3 meters because it's not a big deal. Yeah, just whatever, however they can cram it into their model is all that matters. Yeah. Okay.
If only their model was like Gantenbrink's robot and they had to break it apart to shove it into the freaking shaft they're trying to get it into.
They're working in the real world here. Okay. So in the northern shaft, we could even see the end of a long rod extending up farther into the shaft. The rod was most likely left behind by Wayman Dixon in 1872 when he chiseled open the walls of the Queen's Chamber to expose the lower openings of the shafts, which had originally been closed and thus totally invisible. So yeah, they make invisible shafts and just end them after 3 meters. Like,
Right, because they're symbolic.
yeah. Symbolically invisible already.
Yeah.
Like, why not it just not put them there at all, right?
This is the God.
Yeah.
The guy's like, there's probably shafts in here. No. And then he breaks them open. Yeah, there are. Oh, well,
Yeah.
they just end.
Yeah, they're probably not very long. Apparently, many Egyptologists never bothered to read the Dixon notes, which provided many clues to the length of the lower shafts. Dixon built fires at the base. This is really interesting. Dixon built fires at the base of both lower shafts. So think about it. This guy's working in 1872, so
Smart guy.
low-tech. Yeah. The smoke soon dissipated in the southern one, but not in the northern, suggesting at least that the northern shaft was much shorter than the southern shaft. In fact, it may not extend beyond the level of the Great Gallery. As the pyramid was not closed to the public during our investigation, we were able to work on the upper shafts and that's coming out of the King's Chamber, the ones that go all the way out, for only 2 hours each morning prior to the official opening hour for the tourists. But in practice, we had to share the interior with crowds of spiritualists and their followers, which led to no little frustration on both sides. People in there going, "Oh me, oh wa, you," right? Whatever they're doing. I mean, you can watch videos and you hear them
do that
singing.
again.
Oh me, oh wa, you. That's exactly what it sounds like.
That just blew my mind, man.
Okay. The opening of the lower northern shaft was simply too small to admit the robot at all, so I had made the decision to forget it for the time being and wait for a new and smaller robot. We then disassembled the robot and tried to tow the lower part only through the upper southern shaft using a tow line attached at the upper outlet. So they went up to the outside and dropped a tow line down in there and tried to pull the robot and the bottom part of the robot and its camera up through the shaft that way. Right.
Yeah.
But 9.6 meters in, we ran into a block left unfinished by the builders. This reduced the height of the shaft to only 11 centimeters, and once again, we were stymied. See, like they just didn't finish cutting the... He's just got a diagram here which shows how they didn't finish cutting the trough for the shaft. They had it. It was still there, but for whatever reason, that block was not quite done right.
Yeah, that's very
strange.
Johnson.
Yeah. Somebody let Johnson cut that joke.
The non-Johnson was sick that day.
All right, I guess we'll let Johnson work on this shaft block. All right. Unable to accomplish much more with the robot, we began clearing debris out of the upper shafts and measuring the exact positions of their outlets. We also made a complete survey of the Caviglia tunnel and attached a safety rope to the outlets of the upper shafts. I discovered that of the 14 Maragiolio and Rinaldi measurements I had required for my computer analysis, 12 were imprecise or simply completely false on what was supposedly the best surveyed monument in history. So we spent the rest of the time available to us remeasuring a number of points of the pyramid's exterior and interior. Then there was nothing left to do but pack up and go home for a break of about 1 month. After the problems encountered during their first campaign, I decided to concentrate on the upper shafts. I wanted to get a better idea of their exact dimensions and variations and thus obtain data crucial for construction of the next generation robot, Upuaut 2, that would explore the Queen's Chamber shafts in 1993. So we're going to take a break and we will come back with more Gantenbrink. And we're back. Brothers of the Serpent podcast. Two brothers.
minus one watcher. Talking about the old Gantenbrink endeavor to discover the end of the shafts.
Upuaut!
Favorite robot! Man, if he only had today's technology.
Yeah. I will send this robot up these shafts. That's my impression of Gantenbrink. I don't know what he really sounds like. By now, I had realized that so I'm reading this from sheops.org, which is Gantenbrink's official website, which he has maintained for decades. By now, I had realized that since the upper shafts penetrate to the outside of the pyramid, I could pass a towing cable through them. So I spent the next 4 weeks completing the second robot as a towing sledge, incorporating the video camera from the first one. It was also fitted with a front-mounted rod with 3 lasers to measure the height and width of the shafts as we progressed through them. It was Professor Stadelman who suggested the name in commemoration of the ancient Egyptian god Upuaut. During this same period, the exact dimensioning of the ventilation system was calculated from so Upuaut is what eventually became Anubis. Upuaut is the opener of the way. He was the dog god that led the way into the afterlife. So pretty cool.
Brilliant name for a
name.
robot that opens the way.
That's right. Find secret doors. During the same period, the exact dimensioning of the ventilation system was calculated from my data by LTG using computer simulation. The niches for the ventilation units in the pyramid were rechecked, and all the equipment was again shipped to the German embassy to the GAI in Cairo. So now we go to the second 1992 campaign.
I want to get a huge bulldozer and name it Upuaut. Opener of the way.
That's right. The maker of roads. From here on, it may be interesting to relate the major events of the Upuaut story more or less straight from the notes I kept in my diary at the time. May 3rd. In a meeting in Cairo, Dr. Zahi Hawass agrees to close the pyramid for 1 week to preclude accidents due to falling debris while we clear the shafts. Alluding to the loss of tourist revenue resulting from closing the pyramid, Dr. Hawass asks if I can guarantee success in improving the ventilation of the pyramid. Using a reference of significance in the Islamic world, I tell him, I'll give you my right hand on it, and he is satisfied. May 4th. We begin working on the outlet of the upper northern shaft as directly above the main entrance to the pyramid. As we found in March, the upper southern shaft, because of its steep inclination, is practically free of sand and debris, but the northern one, with a much flatter angle of ascent, requires a major clearing effort. At a height of 80 meters, there is a little opening measuring about 30 by 30 centimeters. Behind that opening, a tunnel over 11 meters long had been dug out along the shaft by unidentified plunderers. So somebody dug down alongside the shaft from the outside of the pyramid by unidentified plunder. Nobody knows who did it, apparently. So they're showing a picture of a guy squeezing down into that tiny shaft on the outside of the pyramid. The tunnel is just big enough, about 70 by 70 centimeters, to allow one man to squeeze in, but it has been filled up with about 4 cubic meters of sand, stone, and debris, which we have to clear out. Once that back-breaking chore is done, we refer to the tunnel as the man killer, because once anyone forces his way through the narrow entrance, he immediately slides down to the bottom of this dark and narrow chute, caught up in an avalanche of choking dust and stone. Inside, there is little air to breathe, but plenty of dirt and grime to swallow. As we clear the tunnel, we also uncover the remains of a previous mission that had failed, probably carried out by Petrie in 1881 and 82. We find a badly corroded, 4-wheeled vehicle which would just fit into the shaft. It is made of solid iron and weighs about 30 kilograms. The very fact that it is still up here convinces me that an earlier attempt to clean out the shaft was made but failed. If whoever tried it actually managed to pass this wheeled ram all the way down through the shaft, he would certainly not have bothered to lug this unwieldy beast back up to the outlet. We discovered that the northern shaft is totally plugged, and the find of the vehicle is not encouraging, but we at least know what we have to do. It is obvious that larger stones are jammed into the shaft. As a result, any attempt to push the blockage down from the top will simply compact the debris further, jamming the shaft even more effectively. So there's a little picture here of this block of iron with wheels on it that somebody was trying to roll down the shaft to ram into the debris to try to knock it down to the inside. May 5th. We fashion our own, hopefully more effective ram by sharpening one end of a truck axle and welding a large chisel onto it. We carry this 40-kilogram construction up to the entrance of the man-killer. There, we attach a rope to the rear end of our improvised ram and then send it sliding down the chute. It accelerates for a few seconds and then crashes into the plug of debris, with the desired effect of breaking up the larger stones into smaller pieces, some of which slide down the shaft, but once is not enough. Only on our third run do we achieve our breakthrough, and hundreds of kilos of dust and debris surrounding our axle pour down in the Caviglia tunnel. The interior of the pyramid is clouded with dust for several hours, but for the first time in at least hundreds of years, the upper northern shaft is clear.
That's awesome.
May 6th. We are now ready to make our first attempt to pull Upuaut 1 up through the northern shaft. We remove the rope from the axle ram and attach it to the tow line, a heavy-duty nylon fishing line of the robot, and then we pull the rope back up to the outlet. Then we attach the robot at the bottom end and begin pulling it up. But there is still too much sand and gravel in the shaft, and the small robot sledge bogs down. The tension on the tow line increases until it finally snaps. The sledge, along with another mass of dust, sand, and gravel, tumbles down to the bottom of the shaft, landing in the Caviglia tunnel. Luckily, the sledge suffers only minor damage. May 7th. Sandstorm. As immensely valuable time passes, I can do nothing but twiddle my thumbs and grit my teeth. May 8th. We began again by clearing debris and a new load of sand left by the storm out of the shaft and the Caviglia tunnel. We fit the man-killer tunnel with a 12-meter-long plastic water pipe which extends out the upper opening. Then we close up the tunnel with masonry to prevent stones from falling into the shaft. At the southern side, we solved this problem by mounting a steel roof over the outlet. The dangerous work on the outside of the pyramid, preparing the ground for the ventilation, requires a total of 2 weeks. Once our cleanup operation is completed, we can finally make our next attempt to carry out a full video inspection of the shaft with the towing sledge. May 9th. Our second attempt succeeds. Upuaut 1 covers the entire shaft from the Caviglia tunnel at the bottom to the outlet at the top. We measure all the internal joints of the blocks along the way, but discover nothing exceptional. At least we experience no major difficulties, except, of course, for the endless jaunts up and down the outer face and in and out of the pyramid for want of a forgotten pen or a measuring instrument or a notebook or whatever.
Oh, my God.
I need my pen. You left it in the Queen's chamber. Oh, okay, got it. God, it would take hours.
Yeah.
May 10th. We install metal bars to protect the end of the pipe at the outlet of the upper northern shaft. We also install the electrical wiring from the exterior to the interior of the pyramid and the electrical control panel in preparation for the ventilation system. And we have to resurvey the Caviglia tunnel because we lost the piece of paper with our original measurements somewhere in the dark tunnels.
Jeez.
May 11th. We built the roof over the outlet of the upper southern shaft. May 12th, we shift to the upper southern shaft and successfully complete the first video inspection of the full shaft, also measuring all the joints. We established that both the upper northern and southern shafts have bends in their length axis. This effectively disproves Robert Bauval's Orion theory. The openings of the shafts are not in line. In other words, from the bird's eye view, they are not parallel to the north-south axis. And there is a very special surprise awaiting us on the upper southern shaft. 5.9 meters before it reaches the outside of the pyramid, the shaft features an arrangement of small niches, like recesses in the wall. So that's like on the interior of the shaft, there's little notches cut out, like like when you look at the camera images, they look like little recesses in the wall of the shaft. But you have to remember, it's like 8 centimeters by 8 centimeters. It's a tiny little thing, so the niches are little bitty weird notches.
Yeah.
May 13th, I show the video of yesterday's shaft inspection to Dr. Hawass, who is delighted and encouraging, but he remains skeptical about the prospect of improving ventilation in the pyramid. I modify the camera on the robot to give us a side view arrangement so we can inspect those niches more closely. May 14th, we conduct a thorough video inspection of the niches on both the sides of the upper end of this upper southern shaft. May 15th, I spend the day chasing all over Cairo to buy the material needed to refurbish the Caviglia tunnel. May 16th, the ventilators from Germany arrive in Cairo. We are busy constructing the brick wall in the Caviglia tunnel to fit the large 2-stage ventilator. We also modify the entrance to the service shaft to improve ventilation. So basically they installed big squirrel blowers and they use the shafts to vent air out.
Right.
And that like seriously cleared up the humidity problem inside the pyramid from all the tourist breathing.
Yeah.
That was causing like serious degradation of the interior stone. May 17th, and like mold growing and
Yeah.
May 17th, we install the ventilators and the necessary electrical equipment and fittings. We also survey the exterior of the pyramid, hoping to pinpoint the potential outlets of the lower shafts. So now they're looking for where the queen's shafts come out, which they never find.
So the two, they cleared both king's chamber shafts.
Yeah. One of them was clear, just had some dust in it because it's real steep.
Yeah.
The one on the other side was a lot shallower, or like it wasn't as steep of an ascent, so it had a big blockage in it that they had to ram out of there. Yeah. So they cleared them both out, and then they installed the ventilators in those shafts.
Yeah.
Yeah. My computer analysis indicates that if they penetrate to the outside, they should do so near the 90th layer. Despite some dangerous climbing and several hours of careful searching on the 80th to 101st layers, we find no sign of any such outlets. For me, this is one of the most intriguing finds of the campaign because it means that enormous effort went to constructing the lower shafts in such a way as for them to remain for all time invisible.
Yeah, it's weird.
Like they were not visible from the interior or the exterior, and yet they went to all this trouble to make these crazy shafts going up through the structure of the pyramid. That's
so. I wonder if the let's say they had a purpose initially during the building phase.
yeah,
Right. So they build the queen's chamber first, obviously.
Yeah.
Because it's down low. And they use these shafts, and as they continue building the pyramid higher and higher, and they get to the king's chamber, and then they start building shafts in the king's chamber because they know they're going to close off. They'll eventually, once they get the king's chamber completed, and they're above the ceiling of the king's chamber, they're going to close off the shafts in the queen's chamber, and then use the shafts in the king's chamber.
So they would do that by how?
So.
How would you close off the shafts in the queen's chamber? By installing those blocks in the wall?
Yeah, and then like say they left like parts of the exterior wall unfinished where the shafts opened up.
You mean the interior wall of the queen's chamber just does not stacked up?
That and the exterior, like where they're closed off on the exterior as well, right?
Yeah.
So I guess what I'm thinking of, however they did it, I don't know. The idea is that they served a purpose during construction, and then, or let's say they built it a certain way and they had the queen's chamber, and then they're like, okay, we need to move up and build another one up higher. So we close off those shafts and move up, build another chamber.
It's possible.
Like, so it's basically suggesting some utility.
Yeah.
That the queen's chamber, like they're like, oh, let's build a bigger one up higher.
Yeah. Yeah. That's possible that they had some kind of construction purpose, but were not necessary to the end product.
Or they were necessary to the end product, but they ended up deciding to build another one up higher for some reason.
And they left those open for whatever
They were
reason.
supposed to stay open, but they closed off the bottom ones because the queen's chamber was no longer used. They're like, well, close it off. We're not using it anymore. But that could be proven wrong just based on I don't know how the blocks were blocking it, or how,
the blocks, they just didn't cut all the way through the last block. That's why it's weird. Like the block that's actually the wall part of the queen's chamber had the shaft in it. They just left 5 inches of rock. Just didn't cut all the way through.
So could they have like removed that entire block?
I don't know.
Put a whole brand new block in there. And had it,
and still would have had it cut. It's so weird.
You're right. Doesn't make any sense. Okay, that's what I was looking for. Something to
like if that would have been what happened, then the entire block would have just been right. They would have just pulled the block out with the shaft hole in it and put another one in there that didn't have one.
Right. So it wasn't like they just put a small block over the hole.
No. An enormous granite block had the shaft cut all the way up into it to the very end and just stopped right before it got all the way through. Strange.
How did the guy find? Like he just banged around on the wall.
He found them in the same place that they are in the king's chamber. But yeah, he went along tapping on the wall, and then he heard, he was like ding 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 ding.
Yeah. Dude,
and then he chipped them out, and there was like, I don't know, some number of inches of granite before he got to the opening. So May 18th, we spend the day working on the ventilation system, conducting operational tests. None of this does any harm to the original structures. I have used a technology to fit in the ventilators without drilling a single hole. We have to attach specially made stainless steel anchors for the security rope. I am forced to guarantee, as the man responsible, that there is absolutely no risk of potentially fatal accidents. Our test of the new ventilation system is supervised by the still skeptical Egyptian authorities in the person of Mustafa Abd el Qadir Isa, Director of Restoration and Conservation of the Giza Plateau, and 3 inspectors. Today's test results. Full speed reduces humidity from 79% to 65% in 30 minutes. Ventilators continue running overnight. May 19th, test results, 30% speed at 12 o'clock, 53% humidity, matching the atmospheric value outside the pyramid for the first time in who knows how long.
Yeah, buddy.
May 20th.
Great achievement.
Test results, 30% speed at 12 o'clock, 53% humidity. Test results, May 21st, 53%. May 22nd, tests results, 53%. At only 30% of capacity, the new system stabilizes and maintains the atmospheric humidity level.
That's awesome.
Professor Stadelman urges Ulrich Kopp and me to write up a statement for the press, which we are happy to do. After all, we are very pleased with and proud of our accomplishments. In a very short period of time, we have helped save one of the most important monuments in the world from further damage by humidity. We have also inspected and measured about 120 meters of previously unknown area in the shafts and have discovered a hitherto unknown element, the niche, in the upper southern shaft. We have also, and thus, demonstrated that with high tech, it is possible to explore areas previously regarded as totally inaccessible. A press conference is scheduled for Saturday, 23rd, which is my last day in Cairo. May 23rd. On this Saturday morning, I receive a call from Mustafa, who tells me that the press conference has been canceled. He says he does not know why. Bewildered and frustrated, I pack up and return to Germany.
That's Zahi Hawass trying to take credit.
Yeah. Ugh. So, the 1993...
Oh, it's so dirty.
The 1993 campaign, March 6th through the 28th of 1993. Preparing the third Cheops campaign. In the late spring of 1992, I'm obsessed with 2 burning questions. First, where do those lower shafts end? And, of course, what is at the end of them? Where do they end? And, of course, what is at the end of them? In fact, it's only the hope of finding answers to these questions that helps me forget the disappointing end to the otherwise very successful second campaign. So in June, I plunge into preparations for the next step. The original project definition foresees investigation of all 4 shafts, but so far we have explored only the upper 2. We now know the lower ones are not simply implied, as conventional Egyptology maintained. After all, we've traveled almost 12 meters into both of them, and both obviously continue. One thing is eminently clear to me at this point. I need a way better robot. That's not how he wrote it, but that's what I said. I need a much improved robot, is what he said. I need a more awesome robot. I begin working out my ideas for Upuaut 2, and by July, I'm completing the computer plans and construction design. In September, actual construction begins, not just on Upuaut 2, but also on the support robot, designed to measure the angle of ascent of the lower shafts down to a 1/10 of a degree. Its clamp gears allow it to ascend by pulling itself upwards along Upuaut 2's power cable, so it comes to be known as the rope climber. Many of the elements I need, especially for Upuaut 2, are very complicated, customized constructions. The gearing, for instance, eventually comes from Switzerland. I learned from my mistake on the first campaign. This time I also build scale models of the shafts so I can conduct extensive trial runs with the new robots. By December 1992, the basic robot Upuaut 2 is completed. The Egyptian Antiquities Organization, the predecessor of today's Supreme Council of Egyptian Antiquities, has asked me to inspect and document the situation of the tomb of Sethos I in the Valley of the Kings. So, in December, I travel to Egypt again and take advantage of the opportunity to conduct traction tests with the new robot in the lower southern shaft of Cheops. While in Cairo, I also show the new robot in slides taken during the second campaign to Dr. Hawass and Professor Stadelman. The latter says it's a great pity that we have no video documentation of the earlier efforts. I suggest bringing along a small documentary camera team for the upcoming third campaign, and Professor Stadelman wholeheartedly agrees. In January 1993, I returned to Germany to complete work on Upuaut 2 and the rope climber, and also to finalize preparations for our third campaign. So, the third Cheops campaign. On March 6th, I arrive in Cairo together with my camera team. March 7th, I spend the day taking care of general preparations and getting acclimatized again. I am scheduled to meet tomorrow with Dr. Hawass and Professor Stadelman. March 8th, Upuaut 2 and the rope climber arrive at the offices of the GAI in Cairo. I go to meet Dr. Hawass, but there is no sign of Professor Stadelman. And I find out that not all of the required paperwork has been taken care of. Dr. Hawass knows about our project and plans, but is of course quite unhappy about this lack of proper preparation. He could easily tell us to turn around and go home again, but in order to not endanger the campaign, he bends over backwards to cut red tape. He requests Ulrich Kapp to inform the GAI that the necessary paperwork must be submitted as soon as possible and generally allows us to proceed anyway. March 9th. We transport all the equipment to Cheops. Once we get into the Queen's Chamber, we set up, check out Upuaut 2 in the video system, and finally the campaign gets rolling. But after only a few minutes, we are again thwarted by an unexpected problem. Because of the difficulties encountered on the last campaign, not being able to get through the shafts, which in one of two places are only 11 centimeters high, I cut down the height of Upuaut 2 as much as I could. Now I discover I have been slightly too thorough. Right after the start of the lower southern shaft, we run into one block which turns out to be the highest in the entire pyramid. Upuaut 2's upper carriage barely reaches the shaft ceiling at this point, so it has insufficient traction. So the second robot is designed to be able to spread out or shrink, and it has tracks on both the top and the bottom to pull itself up the shaft. And if it can't stretch out enough to reach the ceiling, it can't pull itself. Yeah, because it has to drag all the cable up with it behind it.
Turn it sideways.
So Upuaut 2's upper carriage barely reaches the shaft ceiling at this point, so it has insufficient traction. We try to push it past the block, but we don't have a rod or pole long enough to reach into the shaft that far. We give up on the southern shaft and make our first run into the lower northern shaft, again reaching the rod left behind by an earlier expedition before we have to call it quits for the day. So they're about 12 meters in when they reach Dixon's rod. I initiate my practice of making daily progress reports by telephone to Professor Stadelman to keep him informed of what is going on. We spend the rest of the day constructing long push slats to move the robot past the block with the high ceiling. March 10th. The push slats do the job. Once past the high ceiling block, Upuaut once again gains traction and we penetrate into the shaft up to 22.5 meters where we run into the first of what will be many major obstacles. Once again, we are stalled. For the first and only time during this campaign, Professor Stadelman pays us a short visit. How can you even... I would be in there every freaking day, like nonstop, if somebody was running a robot up a shaft that had never been explored.
Yeah.
March 11th. For the first time, we send the rope climber robot up the shaft to measure the exact angle of its ascent. It pulls its way upward along Upuaut 2's power cable. But before long, the rope climber's main V-belt, which is made of plastic, begins to melt due to overheating. We have to back both robots down out of the shaft, and during this tricky maneuver, Upuaut gets stuck. After several attempts to free it up, I have no choice but to lower the upper traction carriage, thus reducing the overall height of the unit. But as soon as the robot gets past the obstruction, it no longer has contact with the ceiling, and both it and the rope climber come crashing down the shaft. The damage is not too severe, but we lose the camera panning gear and a lamp reflector. We also discovered that we have a problem with our video equipment, which is highly susceptible to dust, and there is no lack of that. In playback mode, we're experiencing some pretty serious dropouts. March 12th. I spend a large part of the day making the necessary repairs to Upuaut 2. Since I have to take the entire robot apart anyway, I decide to outfit it with a new set of especially manufactured gears, which are much more stable. At Cheops, we resurvey the exterior of the pyramid to pinpoint the potential outlet of the lower southern shaft. Based on the angle measurements we made yesterday, we know that if the shaft does penetrate to the outside, it should do so exactly at the 90th layer. But as in the year before, there is no sign of any possible outlet. March 13th. More headaches. We decide to construct guide rods, which we can attach to the sides of the robot to help prevent it from getting stuck in the bends of the shaft. But in order to attach them, we require simple M3 screws and nuts. Unfortunately, we do not have any. I spend a large part of the day driving around Cairo in search of these 2-bit items with no luck. Back at the hotel, I ask if someone there could give me a tip about where to find such items. Within minutes, I'm shown into the hotel's own workshop, and it's a dream come true. Everything we need, tools, equipment, and a nice supply of nuts and bolts in all sizes. We finally attach the guide rods to the robot, then realize they're probably too long. We remove them, cut them in half, and refit them. I also repair the rear winch by inserting a tension spring to reduce slack. March 14th. The changes made a big difference in performance. Today we managed to ascend 30 meters, but then we run into a lateral block displacement of about 4 centimeters. Look at that.
So yeah, the block is coming in from the left side.
Right. It's just the next block up is shifted over, and so that looks like the part of the hallway is cut off, basically. Yeah. I'll put these pictures in the show notes. They're very small though, so you'll have to look closely at them. So this forces the robot sideways against the wall. It turns out that the shorter guide rods we attached yesterday are now too short. The danger is too great that if we simply proceed, we won't be able to back out again. We leave the robot where it is in the shaft and stop for the day. March 15th. First thing today, we very carefully back the robot all the way back down out of the shaft. We construct longer rods made of aluminum and again spend most of the day searching for tools.
Jeez.
March 16th. While modifications are being made, we do our filming of the exterior of the pyramid. March 17th. The modified Upuaut proceeds 42 meters up the shaft. March 18th. We make it all the way up to 53 meters and then encounter a 6 centimeter step in the floor. In a shaft measuring about 20 centimeters by 20 centimeters, and for a robot less than 11 centimeters tall, it's like running into a tank trap. Right, so there's the next block is just the floor shifted up. Right, so it's 6 centimeters step up, and the robot can barely climb it. It's an enormous obstacle for this little bitty robot. So, on the horizon ahead of us, we notice a change in the appearance of the shaft. This is visible only on the original video material. I decide to stop at this point and prepare the rope climber to ascend and measure the exact angle up to this point. All right, so we'll take a break and we'll come back. This is awesome. So,
heck yeah.
I'm just going to say real quick, he's skipping past all the interesting stuff he finds in these shafts. He's just telling the story. After I'm finished with the story, we'll go over to what he calls the mysteries, and then he just outlines all this crazy shit that he saw. So,
Heck yeah.
yep. Got a lot of happy birthday wishes on Twitter.
Oh, really?
Yeah. I sent a tweet out saying, "Hey, it's my Snake Bros and fellow co-host's birthday today." Right?
I saw that one. Yeah.
And people were like, everybody was like, "Oh, happy birthday!" Lots of snake emojis.
All right. Yeah. Cool.
Yeah. And party hats and snake emojis.
Thanks, guys. I'm 37. I'm not old.
Yeah, and of course, for his birthday, we are going to go treasure hunting.
Yeah, we're gonna go try to dig up some artifacts.
That's right.
That's so my new thing for like the past, I don't know, 3 or 4 years. I'm like, don't throw me a surprise party.
Right.
Because I might not be there.
That's right.
My thing is like, when the weekend, either before or after my birthday, or if it falls on a weekend, I'm gonna go glad somewhere.
We're gonna go somewhere and find stuff.
Yeah.
So that's what we're going to be doing. Same thing we do every birthday.
Yeah,
Pinky.
and so the early on when we went to the volcano, that was my birthday.
That's right. That's right.
Like, we're going to an ancient volcano, bro.
That's right.
We got to get out in the field. People are going to think we're, a
bunch of armchair theorists here. Freaking
bunch of charlatans.
A bunch of pajama bloggers. As old George Howard
said. You got to get out in the field.
All right. Back to Gantenbrink's story here. On the horizon ahead of us, we notice a change in the appearance of the shaft. This is visible only in the original video material. I decide to stop at this point and prepare the rope climber to ascend and measure the exact angle up to this point. Today, I have to put my foot down. At the start, we were accompanied in the small Queen's chamber by one inspector. As we penetrate ever farther into the hidden recesses of the pyramid, the excitement and suspense are growing, so we are soon joined by 2 inspectors, then 3 inspectors, then by their wives and friends. Today the chamber is jammed with visitors and my team can hardly move. I announce that the number of visitors must be limited to 6 per day. I pass by the inspectorate and show a tape of our progress to Dr. Hawass, who is fascinated. Now, here's where some interesting politics starts to happen here. So he shows a tape of this to Hawass, who's fascinated. The next day, March 19th, Ulrich Kapp, the GAI surveyor who has assisted me so far, is no longer part of the team. He has been, without any warning, sent off to Upper Egypt on some other assignment. Right. So this is the beginning of the getting people out of the way, right? So Hawass sees video, and the next day, he's already...
Yeah, because the whole time they've been thinking, oh, this tunnel just ends.
Yeah. Once again, the V-belt of the rope climber goes soft from overheating. I back Upuaut up 11 meters, then extract the rope climber, all of which consumes a lot of time. Finally, I send Upuaut back up to 53 meters and spend the rest of the day trying to maneuver it over this step in the floor. I leave the robot in place and retire to the hotel, plodding away over this maddening obstacle. I realize that I need more traction on the upper carriage. March 20th. To the upper drive wheels, I need to attach a milled extension with sharper teeth in order to increase traction in the ceiling. The step is the only spot where we need extreme traction. Upuaut has to climb vertically over the step, dragging 57 meters of cable behind it. I don't have the kind of equipment I need to do the job, but I get lucky. At the hotel, I run into some members of a crew who are assembling a cigarette production line in Cairo, and they offer to help me out. Big tobacco
Smokes,
to the
let's
rescue. During my daily telephone report to Professor Stadelman, I received shocking news. Because of internal problems at the EAO, Dr. Hawass resigned from his post yesterday evening. The rumors are flying, but for the moment, no one seems to know what the consequences may be. The same problems would lead to the dissolution of the EAO and its replacement by the SCA. After the reconstructuring, Dr. Hawass later returns to his post as director. So there's political stuff happening. Yeah.
Yeah, that's weird. The first thing I thought of, the weird political stuff happening, obviously, was like their press conference was canceled.
Yeah, that's true too.
And then there's this thing when he comes back and it's like, oh, the proper paperwork's not done.
Yeah.
Oh, by the way, my rules that I put in place to prevent you from being able to do this, I'm gonna bend over backwards to
exactly.
make sure it happens for you.
Right, yeah.
I'm just like, come on.
Yeah. March 22nd. I send Upuaut back up the shaft to the step at 53 meters. Finally, on the third attempt, the robot clears the hurdle and can proceed. The next 6 meters of the shaft show a gradual improvement in the quality of workmanship. At 11:05 a.m., at 59 meters, Upuaut 2 approaches a stone slab which blocks the shaft. This is the famous door. This explains the odd change in appearance we noted back in the 18th as we advanced into the step. What we were seeing was a reflection of this slab. Our video inspection of all 4 shafts so far, a total of about 180 meters, we have seen only blocks made of local limestone. But the final block before the slab is definitely carved from lighter colored limestone, probably originating from the Mokattam Mountains, about 30 kilometers from the Giza Plateau, on the other side of the Nile. This was the material the builders used for the higher quality casing stones of the pyramid's exterior, and for the chamber systems. The workmanship of the last block in front of the slab is also much higher than anything we have seen in any of the shafts so far. What?
I need to see a diagram. Okay, so back to the original hypothesis that was debunked.
Oh, that they shifted, that they...
So it was a smaller pyramid.
Oh, yeah. That could be.
And that's why they get to the casing stones that are basically what was the outside at that time. And they built a bigger pyramid over top of that.
That's good.
And built the king's chamber up higher, put new shafts in it, and then put the casing stones in.
Oh, I see.
So
that's a good idea.
Yeah, all right.
That's a good idea. They would have still had to rebuild the Queen's Chamber interior and still would have almost finished out the shafts for whatever reason.
I don't know how they did. It's just like the what you were describing to me before. It's like the whole block on the inside of the Queen's Chamber had the shaft cut in it and stopped, right?
Yeah.
Well, like the fact that this entire block that was the same stuff they used for the casing stones. Like, we don't know what the casing stones were like on the outside. So,
well, there are some left at the very bottom.
No, I mean, up there where the shaft exits, right? So where the King's Chamber shaft exits. What if the casing stones that were originally there were like the casing stone had the shaft cut into it and stopped?
Yeah. That could be
on the outside.
Yeah, that it didn't come all the way to the outside with the casing stones there. Yeah, that's possible. Yeah.
Anyway,
so you're implying that like what they're actually looking at here are the original casing stones of the smaller pyramid, maybe.
Yeah.
Yeah, that could be it.
So I want to, anyway, we'll look at a diagram of it.
And that would also make sense when they drilled through it, they saw just another block right past it.
Right.
And it's a rough one, implying that that was the outside of the original pyramid. Yeah, could be. That's totally possible. That's a good idea. Okay. As we approach the slab, we see 2 dark streaks upon it, which upon closer inspection turn out to be copper fittings. And there is something else. The face of the inspector sitting next to me at the monitor has become chalk white. He draws my attention to 2 round white marks on the copper fittings. These are seals. These are seals, he exclaims, visibly shaken. We must stop work immediately and inform our chairman. The excitement in the Queen's chamber is palpable. For a variety of reasons, we know we have discovered something of great significance, but I have no choice. I leave Upuaut 2 parked in front of the slab, and we retire to our hotel in Cairo. I call Professor Stadelman to give him the news. So this is like, to me, when I first read this part really struck me. Like, the guide who's with him, like, all the color drains out of his face. Right? He describes him as turning chalk white. These are dark Arab people, and basically, right? The dude, like, is terrified or whatever. Something has happened to him, and it's sort of unknown. Like, he just, and then he claims that they're seals, like, you know, like a seal on a door or whatever, right?
Not like a signature seal, like you stamp into
It's
the
not
wax.
clear. He just says, these are seals.
Yeah.
And you're like, what are you talking about? Right?
Like
and
the
you can
animals?
see him. He shows the 2 white circles that can be seen.
Yeah.
Yeah, it says the face of the inspector sitting next to me at the monitor has become chalk white. And then he starts shouting, these are seals. He's visibly shaken, and he says we have to stop work immediately.
Yeah, that's really weird.
Like he's terrified or something happened to him, and it, like, you know, the dude was like really very upset.
Yeah.
For whatever reason. He was scared. That's weird, right?
Yeah.
Are these really seals? The professor asks. I simply repeat what the inspector said, adding that I myself have no idea what Old Kingdom seals look like. Within an hour, both Professor Stadelman and Dr. Hawass arrive at the hotel. Together, we view the video of the day's discoveries. About the seals, Professor Stadelman is quite adamant. He says no such round seals were ever used in the Old Kingdom. But much later, together with a German Egyptologist, I was to investigate this issue more thoroughly and discover that this is not necessarily true. The usual practice in the Old Kingdom was to roll a cylindrical stamp over a piece of clay to create a so-called roll seal, or a cylinder seal, like the Sumerians did.
Right. I don't understand how those circles could be. I don't get it,
But not always. Although very little is actually known about the appearance of Old Kingdom seals, it appears that some were indeed made of white gypsum. And a careful scrutiny of our video images from the shaft reveals several bits of gypsum in the sand some 15 to 20 meters below the stone slab.
Oh, so he's thinking that the seals were put in there and then the copper was like molded in to hold them in place?
Yes. Yeah. And the seals represent do not break this. Basically, it's a...
Okay.
You know, if it was sealed, it's sealed shut. It's like, don't open it. It's a seal, like...
Yeah, so the copper...
The copper is holding the gypsum seal stuck to the slab.
Oh, it's freaking out. So they bore a hole into the block, they slide the seal in there, then they have maybe they make like a sort of a little cut or a groove for the copper.
Yeah.
And then they mold the copper into it.
Yeah, the copper is like a hook. It's also drilled in.
Oh, okay.
And
bent over.
And bent over to hold the seal to the slab.
I never understood that. So
it's pretty freaky.
Okay, I'm not going to jump into the future. keep going.
In any case, on this momentous March afternoon in Cairo, both Professor Stadelman and Dr. Hawass are absolutely delighted and very complimentary. Professor Stadelman says my team and I should prepare a press statement on our findings, and Dr. Hawass adds that the Minister of Culture has to be informed immediately. March 23rd. As of every morning, the first thing I do upon reaching the Queen's Chamber is to turn on Upuaut's video system. During those suspenseful moments before the first image from Upuaut's camera appears on the monitor, I say, "Good morning" to Upuaut. This has become a popular custom with everyone present, so today there is a true chorus of good mornings. "Good morning, Upuaut," everyone says. Unfortunately, no one representing the GAI is present, but there are representatives to the inspectorate. Today, we make a more thorough video inspection of that marvelous slab. Subsequently, it has become known, perhaps unfortunately, as the door. This popular name, of course, implies that the slab actually serves the function of a door leading to, well, who knows what. But until we can peer behind it, or perhaps even open it, we will never know for sure what it really is and what it meant to the builders of Cheops. So, for the time being, it might be more appropriate to simply refer to it as the USO, the unidentified stone object. That's great. I back Upuaut out of the shaft, and we use the rest of the day to continue our investigation of the lower northern shaft. I send the robot up to the metal rod we have seen before. and farther along the rod until we reach a sharp bend at 18 meters. I leave it at that and extract the robot from the shaft. March 24th. I spend most of the day preparing the rope climber for a trip up the lower northern shaft. During our daily telephone conversation, Professor Stadelman proves to be unhappy with the draft of the press statement and requests a rewrite. March 25th. I send Upuaut 2 and the rope climber up the lower northern shaft to measure the exact angle of ascent and more closely inspect that rod. The temptation is great to send Upuaut around the sharp bend at 18 meters, but since our short guide rods have suddenly turned up missing, the danger is too great that the robot might get stuck and not be able to return. Yeah.
The guide rods that they made to fit around it?
Yeah, to keep it in the middle of the shaft. Yeah. I extract both robots. We do a thorough cleanup of the Queen's chamber, pack up all of our equipment, and leave Cheops. During my daily telephone report to Professor Stadelman, I notice that he seems nervous and worried, and he wants yet another version of our press statement. March 26th. We transfer all the equipment to the GAI so it can be sent back to Germany. During dinner, Professor Stadelman again proves to be unhappy with the draft press statement. More changes. March 27th. We draft yet another statement to the press, but Professor Stadelman is still dissatisfied. He now says we shouldn't publish anything until May, or perhaps even November, when our next campaign would presumably begin. March 28th. Thoroughly discouraged by this reaction to our discoveries, I send a fax to the GAI announcing my withdrawal from our joint project and fly home to Munich.
I wish you would give more information about the changes they wanted. Like, what was the press statement?
Yeah, and why was the guy worried and nervous? They found something momentous, and now everyone's flipping out.
Yeah.
And some people apparently aren't happy, and Hawass is pulling strings in the background, and crazy political shit's happening. And they never let him release a press statement on any of the stuff they did. This is why he made this website in the first place. All right, so let's go to the mystery. That's the end of the story, basically. He never was able to go back.
I think the reason why they didn't like the press statement or any of it at all was because whatever they were dealing with was conflicting with their story.
Yeah.
Right?
Yeah.
Already disproved their BS about the shafts being ceremonial.
Yeah.
And then, now there's something significant at the end of it, and they're trying to... They need more time to figure out how to work it into their bullshit, basically.
Yep.
It's frustrating.
Okay, so there's two mysteries, the why mystery and the why for mystery is what he calls them. The why mystery. Unraveling the why mystery, that is, why there are shafts in the Cheops pyramid, necessitates a bit of background information. The many monuments in Egypt all display an evolutionary history which can be traced through time. In the case of the pyramids, we know that the stunning structures of the Giza Plateau all had predecessors. Before them, the Egyptians built square step pyramids. Before that, they erected rectangular step pyramids right at the start, the so-called mastaba, which were basically just large slope-walled rectangles rounded at the top. So, we can follow the expertise of the builders through the centuries until it culminates in the structures of the Old Kingdom, whose features we can detect in the more primitive forms of the earlier epochs. That is, of course, with the single exception of the shafts of Cheops. These striking features are unique. They have neither precursors nor antecedents. There were no shafts in earlier pyramids, and there are none in later constructions. Indeed, some early books on Egyptology cite the two small rectangular indentations of the burial chamber of the later Chephren pyramid as antecedents of the Cheops shafts, but the Chephren indentations are only a few inches deep and in no way constitute even rudimentary shafts. Since our video mapping of the Cheops shafts, we know that they are by no means simply implied or insinuated. They are complicated, extremely long architectural features, which required enormous extra effort to build into the overall structure. Thus, the Chephren indentations in no way constitute a parallel or antecedent to the Cheops shafts. Right?
Yeah.
Since the Cheops shafts all measure only about 20 centimeters by 20 centimeters or 8 by 8 inches, they were obviously never designed for human passage through them, so what were they for? Over the years, many suggestions have been made. 1. They are air shafts. Well, the answer to this is a straightforward no. The lower shafts were closed at both ends. The upper ones, if they had been left open as air shafts, would have exposed the burial chamber to birds, snakes, rats, etc., an idea certainly abhorrent to those dedicated to protecting the remains of the pharaoh at all costs.
Well, that's assuming there
was a burial
pharaoh
chamber in the first place, yeah.
Right.
He's just going with their standard model.
Right.
They called them air shafts, right?
Yeah.
2, they are light or star shafts. No, all the shafts bend, often several times. In addition, all the shafts begin at their lower ends with horizontal sections about 2 meters in length, so there is no way light from any source could ever have penetrated from the outside into either of the chambers. In several parts of the shafts, with the exception of the lower southern one, we even found extreme angle fluctuations. It is therefore ridiculous for anyone to claim that the shafts could ever have pointed precisely to certain stars. Given the many angle fluctuations, the shafts could be construed to be pointing at some 100 different stars, especially if construction of the pyramid is gratuitously redated to match specific stellar constellations. 3, they are water shafts. This is nonsense. All the shafts have open joints along their floors. Any water entering from the top would disappear through these gaps and cracks long before it could ever reach the burial chamber. Not to mention the fact that the idea of water in the king's chamber would have horrified the builders, who went to enormous effort to protect the pharaoh's remains from all outside influences. 4, they are energy shafts. In other words, the Cheops pyramid is some kind of hydrogen power plant. This very simply contradicts at least 100 years of archaeological evidence. So what? That's my answer to that. So what if it contradicts all that? In addition, the shafts were not completely sealed, see above, at any time, so there was no way to convey energy through them. 5, they are spirit or soul shafts. This is the most probable explanation based on the solid data we have available to us. At least it corresponds to the system of religious beliefs of the ancient Egyptians as far as I can tell. But this brings us to a truly great mystery. If they were designed as soul escape routes, why were such shafts built only during one single generation? That's a good question.
And why were they closed off by more stone?
Right. And why were none constructed before or after Cheops? Possible reasons. 1, this phenomenon indicates the existence of a religious revolution, such as in the case of Akhenaten's Amarna culture. It is possible that a single generation took a radically different approach to religious rituals, but as is the case with the Amarna culture, such religious revolutions leave behind different kinds of evidence and are thus well documented. There is no such evidence or documentation relating to Cheops. 2, the shafts simply constitute an afterthought or an insignificant architectural change. This hypothesis defies all logic and basic engineering knowledge. The shafts, despite their small dimensions, greatly complicated the construction and required massive static changes, endless additional work, time, and energy. Any builder forced to penetrate vast horizontal layers with diagonal structures faces enormous challenges and headaches, not to mention the fact that both northern shafts had to be bent several times at different angles, a masterpiece of engineering to get around the vast obstruction of the Grand Gallery.
Oh.
Like that one shaft has to go around the Grand Gallery. It bends all over the place to get around.
Which one is that? One of the Queen's Chamber shafts?
Both northern shafts.
So the King's Chamber.
Yeah,
and the Queen's...
it has to bend too to get around the Grand Gallery. Yeah.
How can the King's Chamber?
Because it's on the King's Chamber's on the same level as the top of the Grand Gallery.
Oh.
Right. So that shaft coming out has to go around the tip. Yeah. Not very much. Not nearly as much as the Queen's Chamber shaft, which has to go all over the place. But it has to bend a little bit to get around the Grand Gallery.
They had to have it.
Yeah. They had to have it.
They had to have it.
The Y4 mystery. If one generation thought it was necessary to provide the pharaoh an architectural escape route for his soul, one shaft would certainly have been enough. So this question is, why are there 4? Why 4?
Why 4? That's great.
One shaft would certainly have been enough for the soul to ascend to the all-important northern sky. But the King's Chamber...
Wait a minute. Okay, so let's go with the mystical, mythological standard model BS.
Yeah.
There's the Kef and the Ka.
Yeah.
Right?
Yeah.
So the Ka is, I think, watcher, check me out. Dang it! The Ka is like the actual. It's like the consciousness essence.
Yeah.
It's the thought essence of your existence.
Yeah.
And then Kef, I think, is the other one. Mm-hmm. Is the body essence of your existence.
Okay,
so
I can't remember the Kef one, but I remember the Ka.
Yeah, one
Ka
of them
can be held in a statue or...
Yeah, well, I don't... Okay, so I think the Ka is your
mind.
Your mind, your consciousness essence in soul form.
Okay.
And the Kef is your body essence in soul form. So, like, we have apparitions or whatever of ghosts.
Gotcha.
Like, it's a combination of...
Kef
it could be
Ka.
Just one.
Yeah.
Right, if it's just this image
mindless...
of like the body walking up the stairs every night at midnight,
doesn't respond
whatever
to any external things.
Right,
yeah.
that's the Kef. That's the Kef. It's this remnant of the spirit of the body.
Okay, that's cool. Yeah,
yeah. So you got to have 2 shafts, bro. 2 shafts.
Still, why 4?
Well, it's a king and a queen.
Right.
I'm just going with the standard model.
But the queen is never let out. She's not allowed to get out.
Well, she had a smaller pyramid. She got out. She died. She got out.
Oh,
And then
okay.
they built. And then the king was like, "I want to be on top of her."
Yeah.
So he built a bigger one.
God.
Well, okay. Not like
I
that.
want to be on top. But she's already gone. I don't care. Okay. But in fact, we find a total of 4 shafts, the 2 upper ones leading out of the king's chamber and 2 lower ones related to an additional room which has become to be known as the queen's chamber. No one has ever, excuse me, no one has ever been able to explain the function of that second chamber, however, especially in light of the fact that there is no tradition of any queen of Egypt ever being entombed in the pyramid of her husband. For whose soul might those 2 lower shafts have been designed? The upper shafts have outlets on the exterior of the pyramid. The lower ones do not. The upper shafts penetrate directly into the king's chamber. The lower ones originally stopped 8 centimeters short of penetrating into the queen's chamber. 8 centimeters of solid stone block with absolutely no indentation or any other indication anywhere of their existence on the interior of the chamber. Or the exterior of the pyramid itself.
I love the way Graham Hancock talks about this thing. It's like, it's almost as though the builders had human nature in mind, like the inquisitive mind.
Yeah.
And so
It's a puzzle.
Yeah. The indication of the shafts in the queen's chamber were in the king's chamber.
Yeah.
That's so freaking cool.
Yeah.
It's like, so now that they figure these out, now they might start thinking about this other thing.
Right.
Like, And sure enough, somebody does that.
And then they're like, well, these must go to the outside. So they go all over the place looking for it, and they're not
Yeah.
out there. And they're like, what? So now we got to build a robot to go find out where they go because they don't go outside. And then we find out that there's a door.
it's just
And they
freaking
have
awesome.
seals on them. And then we're like, oh my God.
It's freaking awesome.
Thus, those 2 lower shafts were constructed at enormous additional cost and effort to be totally invisible. They were only discovered to exist by a combination of intuition and luck in 1872. Making the 2 lower shafts invisible was not an effort to protect them or something to which they might have been led from plunderers. Prior to the first intermediate period of ancient Egyptian history, pyramid builders did not take into consideration the possibility of plundering. For them, the power of the pharaoh in life and in death was so awesome that no one would ever think of desecrating his tomb. Thus, defensive measures at that time, e.g. plugging blocks, probably had only symbolic significance. So, for whom, if not for plunderers, did the lower shafts have to be invisible? It requires relentless, painstaking effort over a construction period of some 10 years to keep such closed systems free of debris, waste, and dust. Think about that. As you're building it, the bottom's closed off. You can't let anything get in there. Or the bottom has to be open until you finish. And then that just is, it doesn't seem feasible.
Right. As you get halfway up, that tunnel is so long. Like, how are you going to clean it out?
Right.
And yet he opened it up and it...
Yeah, nothing fell out. Well, no, it's actually there were some objects that were in there. It was a little ball and a hook of some kind, which it's interesting when we get later on, you find out that that there are scrape marks and other things. But anyway, we'll get to that. Okay. It requires relentless, painstaking effort over a construction period of some 10 years to keep such closed systems free of debris, waste, and dust. The Giza Plateau suffers an average of 4 major sandstorms each and every year. That makes about 40 such storms during the shaft's construction. So for that entire period, the shafts had to not just be covered, but nearly hermetically sealed. On top of all these considerations, since our March 1993 campaign, we know that at least one of the 2 lower shafts, the southern one, leads upward to and is blocked off by an extraordinary feature, a finely worked slab of special limestone, of a kind otherwise used only for the pyramid's exterior sheathing and its interior chambers, and that slab is adorned with 2 copper fittings. The shaft of Cheops presents us with an array of contradictions and riddles, all of which lead to that slab of polished limestone. When we discover what lies behind it, we will almost certainly learn why those 2 lower shafts were specifically constructed to be totally invisible, and we will finally gain the long-sought key we require to unlock the overall mystery of the Cheops pyramid. Okay, so the findings. General remarks. With a few minor exceptions, the 4 so-called air shafts of the Cheops pyramid were constructed in accordance with one unvarying system. The shaft roof and both walls were cut from one block to form something like a stone canal. The floor was provided by a second block, effectively sealing the shaft from below. So the way I always say it is you take one block, you cut a trough in the top, you flip it over and put it on another block, and then you have a shaft.
A square trough,
yeah. Okay. Thus, the joins connecting the upper blocks normally ran perpendicular to the floor of the shaft. Each of these sets of 2 blocks had to be fit into the horizontal layers of the pyramid using wedge-shaped blocks. Thus, each shaft sequence required the special fabrication of 4 blocks, as we observed in the Caviglia tunnel, in the Mankiller tunnel, and the outlet of the upper southern shaft. The overall static structure relevant to the shafts measures approximately 2 by 4 meters. And he's got a picture here of like the shaft construction.
Oh my God.
So you've got all the horizontal blocks, and then you have these wedge-shaped ones that are holding it into the rest of the pyramid structure. And there's this little robot going through there.
Oh, that's freaking awesome.
This construction system gave rise to a continuous diagonal joint at the floor of each shaft, running through almost half the pyramid. Considered statically, such continuous joints are extremely dangerous. They can be regarded as something like a sliding board. The sliding of a great mass along such continuous joints would necessarily lead to the collapse of the chambers. The ancient builders were obviously aware of this problem. In the Mankiller tunnel, for example, we found a so-called griddle stone. Thus, the pyramid builders obviously went to great effort to deflect the sliding forces, a measure which speaks for their highly advanced understanding of static processes. So griddle stones were basically things that socketed the diagonal shaft blocks into the layered system to keep them from trying to slide down into the chambers. The whole system, could slide down into the chambers and just pile up in there. It would be catastrophic.
Yeah.
Okay. Using the robot Upuaut 1, we were able to measure exactly the width and height of the upper 2 shafts, or the 2 upper shafts along their entire lengths. Normally, the shaft width never varies by more than 5 millimeters, but the shaft height fluctuates by up to 2 centimeters, with the exception of some uncompleted shaft sections. On average, the shafts measure 20.5 centimeters in width and 21.5 centimeters in height. But in the vicinity of the chambers and the sharply angled shaft segments, the fluctuations are larger. Here, shaft width varies between 17 and 22 centimeters and shaft height between 14 and 23.5 centimeters. As we verified in 1992, the upper southern shaft emerges on the exterior of the 101st layer, the upper northern shaft at the 102nd layer. In this regard, Maragiolio and Rinaldi report incorrect values. The shaft blocks were probably made, for the most part, from local limestone. This supposition is supported by the numerous imperfections we detected in the blocks. Okay, let's see.
So he actually recorded all the angle changes and...
Yes, that was what the climber was for.
Yeah, I would like to see that data.
Yeah.
Like see that illustrated in 3D.
Yeah.
Like a 3D
And
model.
he does have 3D illustrations on his website here. So I'm trying to find the...
And they would... So I'm wondering how they change, like if there was, excuse me, any pattern to, say, the length of a specific trajectory and angle, and then the angle change... I'm trying to think of the right word. Like the angle change on, the X and Y plane versus the angle change on the Z plane.
Yeah.
Like if you looked at all those numbers, would there be, some type of pattern?
Yeah, and a lot of them are due to settling or various like permanent static forces. Plus, a static force is just like you got all this weight on it, and
Right.
then something happens like an earthquake and it shifts stuff.
Right. But I'm thinking the intended angle changes, vertical and
yeah, I don't
horizontal
know.
angle changes, and then the length of, how long they're maintained. It would be cool to look at that data.
Yeah. Let's see if I can find what I was looking for here. Maybe we'll go ahead and take a break. We'll take the last break. So let me go through this and find. There's other stuff in here that I want to read. I've got to find it.
Yep. Hold on, your snake tails. We'll be back. some music by Tyrell Rolling Stone of $50 Dynasty. A fellow snake bro.
It's my band.
Yeah, thanks for that, buddy.
Yeah, it's good music. Great running down a shaft and a pyramid music.
Yeah.
Trying to get away from the giant robot. Something like that.
So did you find what you need there?
Yes, I did. I found it. Okay.
All right.
I was looking for the specifics of each shaft that he found, all the different stuff. So, very interesting things here. Like, this isn't widely said, and I wasn't sure until I went back and read this, but all the shafts bend. Okay? They all have bends, and not just the bottom ones. All of them do. So this is one of the reasons why he says that, like, he doesn't buy the whole, like, star alignment thing, and I kind of agree with that. Like, they don't point at stars if they're bending all over the place, or maybe they do point at stars in some different way, more complex way. Like, we did talk about that one time about how maybe the bending was showing some ancient connection that was lost. Remember that?
I seem to remember thinking that, let's say it took them, or they're illustrating like the processional flow.
They're pointing at multiple different times, yeah. And
that's what I'm saying.
You got these bends, yeah.
So if you figured out all the angles and everything, and then figured out all the directions that would point at whatever stars, maybe they're mapping something out.
Right. But the thing about it is that the bends have very structural reasons. They have to go around.
Right. That's yes, exactly. Yeah. So, well, you're going to build around the Grand Gallery.
Right.
You know.
So the upper shafts also have to do this. So this is what he says.
But it also makes sense in an engineering sense that, well, we've got to go this way. We're trying to get out. Like, say they had a specific area they wanted to get out, which that seems probable because why would you bend if you just could go out anywhere?
Yeah.
Well, just point it that way because the Grand Gallery's in the way and make it straight.
Yeah.
Well, they wanted to go around it because they wanted it to come out at a specific spot.
Yeah. Yeah.
So if you measure, you know, if it comes out, if you measured where it starts and where it ends and then draw a straight line, then you've got a star alignment.
Yeah, possibly, yeah.
But, you know, that's not necessary. Like if they had a specific reason for where it came out, because that was what was important.
And it has to come from that chamber, and then it has
and that's important. Yeah. Then you would say, well, let's go this way for a little bit. Because you don't want to you don't want to make a curve. Right. That's way too hard. Yeah. So you figure a straight line for so many courses of stone. And once you get up to that course, it's like, all right, 14th course, we need to change the angle and the vertical angle by this much. And that's the new direction for the next 5 courses. Right.
Okay, so upper northern shaft. So this is the King's Chamber northern shaft. The lower end of the shaft begins with a 2.63 meter horizontal section through the first block, which, like all the wall stones of the King's Chamber, is made of granite. At this point, the shaft is made up of 3 stones. At block number 2, the shaft angles upward and simultaneously bends towards the west. So it bends right off the bat. It goes straight in from the King's Chamber and then immediately bends west and up. Okay. The connection of this block to those below is very unusual. And he says for details, see Cheop's shaft drawings, which he has all these CAD drawings you can look at. From block number 2 upward to the beginning of block number 5, the block floors have been almost completely destroyed. In 1817, Captain Caviglia dug open this section from below to form a tunnel which follows the bends and angle changes of the shaft. Thanks to this tunnel, we were able to conduct very exact measurements on this section of the shaft of the upper part. 2 interesting conclusions can be drawn from the shaft bends and changes in angle of ascent. Number 1, until 1993, I'm just going to read this first one. The second one's really long. Until 1993, when we discovered that the lower northern shaft also bends to avoid the Grand Gallery, or the Great Gallery, it was generally assumed that the bends in the upper northern shaft were simply the result of a planning mistake made by the pyramid builders. In other words, not until actual construction was underway did they supposedly realize that the extension of the upper northern shaft conflicted with the Great Gallery. Based on our present knowledge, this assumption no longer makes sense. The northern shaft's structural conflict with the Great Gallery was obvious to the builders much farther below during construction of the shafts emanating from the Queen's Chamber. Based on the experience gained there, the builders could have shifted the King's Chamber shaft inlets farther to the west in order to correct for their planning mistake without great effort. Instead, the builders repeated the conflict situation, a fact which again cost them immense time and energy. There is only one reasonable answer to this apparent dilemma. The position of the shaft inlets in the chambers was critically linked to an exact spot. so no shifting of the inlets could be tolerated.
Yep.
All right.
Either that or you had one Johnson working on the shafts and the other Johnson working on the Grand Gallery, and they didn't communicate with each other.
Yeah. Yeah, Johnson 1 died and didn't tell Johnson 2. Okay, block number 23, measuring 4.37 meters, is the longest we found during our investigation. Its ceiling is partially unfinished. The ceiling of block number 24 is also unfinished. From the end of block number 25 to block number 32, where it emerges from the pyramid's exterior, the shaft runs through a tunnel dug by unknown plunderers. The digging of this tunnel, which we came to refer as the Man-Killer, completely destroyed the ceiling and east wall of the shaft. The west wall, still intact along the entire length of the tunnel, displays no special features. Thus, an arrangement of niches of the kind we discovered in the upper southern shaft cannot have existed here, otherwise we would have found at least some traces of a recess in the undamaged west wall. The Man-Killer tunnel is accessible from the outside of the pyramid, so we could manually measure the angle of shaft inclination through this section. The average angle is 31.2 degrees, determined by 5 measurements made over a length of 11 meters. Okay. Let's see. Go to the upper southern shaft. Like all the other wall stones of the King's Chamber, block number 1 is granite. At this inlet point, the shaft is made up of 3 blocks. Early treasure hunters dug a round tunnel into the block above the shaft itself. This initial horizontal shaft segment is 1.72 meters long. At the beginning of block number 2, the shaft inclines at an angle of 39.2 degrees. This segment of the shaft is nearly round in cross-section and seems to have been enlarged after its initial construction, probably by the same treasure hunters as mentioned above. At block number 3, the shaft inclines more sharply, reaching an angle of 50.54. Interesting. Which it maintains at the end of block number 4. Well, oh wait, it's 52 degrees is the angle of the outside. Yeah. Block number 5 is not accessible to conventional measuring procedures. Here, our video image shows that the shaft's angle of descent declines from this point all the way to the outlet on the pyramid's flank. The shaft maintains an angle of 45 degrees. So despite the extreme fluctuations of the initial section, the shaft seems to proceed with great exactitude and constancy. From block 12 onwards, Upuaut 1 detected sunlight, which until that point was blocked from view by a bend in the longitudinal axis. We were able to use the tiny dot of sunlight on the horizon ahead of the robot to evaluate very precisely the video material. This even allowed us to determine the amount of longitudinal bend in the shaft. The far end of block number 5 is unfinished. As a result, the height of the shaft drops to only 9 or 10 centimeters. This is an obvious example of inferior workmanship, Johnson, what we refer to as a Monday morning block.
We refer to it as a Johnson block.
That's right. Block number 5 was almost certainly inserted without authorization from the architect or master builder. The discovery of a number of such unfinished blocks in both upper shafts and in the lower southern shaft as well would seem to indicate that the shaft builders made up a separate working group. This group apparently lagged behind at times, pressured by the rapid rate of growth of the pyramid layers and the construction of the chambers. This would also explain the extreme angle fluctuations in the vicinity of the King's Chamber. Between block number 15 and 16, we discovered a vertical joint. In the shaft, such joints which have a distinct static function otherwise occur only proximate to the chambers. Okay?
What does that mean?
In other words, they've got this joint that they only see near chambers, but this one's not near a chamber that's known.
Okay.
Implying that there may be an unknown chamber.
What?
It is a complete anomaly to find a vertical joint fully isolated in the nucleus of the pyramid. Since it requires much greater effort to shape and fit the blocks in such an arrangement, we can assume that the builders must have had significant structural justification for going to the trouble of deflecting forces into the horizontal plane.
Okay, I'm getting it.
This vertical joint is located about 12 meters above a point in the lower southern shaft, which is subject to extraordinary static influences. The overall statics in this area seem to differ from those in the other shaft segments. For a construction engineer, this is a significant clue to the possible existence of an as-yet undiscovered structure in the vicinity of these static anomalies. This is what I'm talking about.
This is a freaking map.
Everyone knows about the door, but there's so much other stuff that he found, like that.
Yeah.
That just is never in the popular media about this, and it's so important, right? Like he thinks the hype about the door is stupid, but he's like, here we have this thing that's an obvious point to that there is some static forces that we don't understand that should not exist in a bunch of layered blocks.
Right.
If there's no hole somewhere nearby,
Dude, that's freaking
Okay.
awesome. So it's almost like the shafts are a
Drawing
map.
you a map, yeah, if you can infer it, yeah.
Yeah.
At the end of block number 17, the shaft bends slightly to the east. We were able to determine this during the video evaluation on the basis of Upuaut's tow line, which ran parallel to the shaft. In both shaft walls at the end of block number 23, we discovered an arrangement of niches, whose function remains unknown. Professor Stadelman suggested that this might constitute a parallel to the closure stone, i.e. the slab in the lower southern shaft. He meant that the niches could have formed a part of a former mounting structure for a shaft closure, like a door, right?
Yep.
At first glance, this hypothesis would seem to make sense, but closer examination of the data we collected makes it highly questionable. 1. The eastern niche forms a groove, the western niche a recess, extending to the end of the block. So a small plugging stone of the kind envisaged by Professor Stadelman would be held in place only on one side. The groove on the eastern side would serve no purpose.
But if you had to insert a slat, then you would have a groove on one side where you could turn the block at an angle, insert it into the groove, and then the other
Slide it
side is
down.
completely
Yeah.
taken out all the way to the end, so you could let it curve down into place.
Right. A small plugging stone could not have been lowered into the shaft from above, as Professor Stadelman had suggested, because the shaft in block number 23 is wider than block number 24. Thus, a plugging stone narrow enough to fit the dimensions at the top of the shaft would simply slip past the niches. Professor Stadelman's hypothesis allows for the possibility that the plugging stone was embedded in place during construction of the shaft itself. He doesn't explain, however, how this stone, embedded 12 meters deep into a shaft measuring only about 20 by 20 centimeters, was later removed without doing even the slightest damage to the niches. Even if we choose to assume that the groove in the recess originally held a stone slab, we still face the problems mentioned above. Any such slab would have to have been inserted before the corresponding block was set in place, and thus could not have been removed later without damaging the niches. The vague possibility remains, of course, that a stone slab was planned at this spot but never actually built into the construction. Even this case, however, does not constitute an exact parallel to the situation in the lower shaft, because the upper shaft ceiling has no recess like that in the lower southern shaft at the slab.
Another lame possibility is that the
Johnson just didn't do it right.
Well, the stone block was actually being formed for some other purpose, and then they're like, "Oh, well, let's use
repurpose it.
Let's repurpose it for the shaft. We got to get this thing moving." Yeah.
The upper butt joint of block number 23 is also unusual in that it forms a rectangular concave profile. It is also remarkable that here the floor joint is aligned with the shaft joints. That's another static problem.
So, like, it's hard for me to envision what you're saying.
You have to look at his drawings. He's just pointing out structural anomalies in the shaft construction at certain points. The upper butt joint of block 23 is unusual because it forms a rectangular concave profile.
Okay.
It is also remarkable that
So
here
it's only touching around the edges, basically.
right. It's also remarkable that here the floor joint is aligned with the shaft joints. Normally the floors and the shaft blocks are not
Yeah. They're like
So for whatever reason, the floor block and the shaft block end at the same place in this part for whatever reason. So he's also implying that there's something structural going on here that we can't see. It's
Right.
around the shaft, and that is shown in these.
Right. This is why you have to have these two joints aligned right here because there's something else
going on somewhere else that makes blocks. You have to play Tetris with the blocks.
Right.
Yeah.
Freaking cool.
After the last remaining original block, number 25, the shaft extends another 1.7 meters, restored in the more recent past before it outlets on the flank of the pyramid. Okay. So, the lower northern shaft. So this is coming out of the Queen's Pyramid, Queen's Chamber.
The northern shafts are the ones that have to go around the Grand Gallery,
Yeah.
right? Okay.
After an initial horizontal section of 1.93 meters penetrating the first block of the Queen's Chamber wall, the shaft bends upwards. Based on 14 measurements made over a distance of 17 meters, the shaft's angle of ascent fluctuates between 33.3 and 40.1 degrees of ascent.
33.3.
Yeah. Block number 4 clearly shows that a change in the angle was made at this point. To that end, the builders even cut the shaft 2 centimeters deep into the beginning of the floor block. So the floor block, which is normally just flat, they actually cut shaft into it to make it work. So the floor...
Because it was sitting up higher.
Yeah.
Like, that kind of makes it interlocking.
Yeah.
But if it was staggered with the block on top, then the block on top would have had to like in other words, if the floor of the block had to have a trough cut in it, then the block laying on top that went across that joint would have to be cut away.
Right. Yep. They cut they cut out the floor for whatever reason and then sort of ramped it up to make that stop. Right. So when you hit that block, it's cut 2 inches in, and then as you go up the block, it's ramped up until it's no longer being cut into it. And for whatever reason they did that. Who knows why? There may have been imperfections in the stone they were using on the shaft block, and they cut it out of the floor. I don't know. I have no idea. Or maybe they were trying to make it fit something that wasn't working. You know, they were trying to make an 8 inch by 8 inch square, and sometimes they had to finagle it.
Improvise,
a little bit. You had to help it.
You got to help it a little bit.
Only further measurements in the still unexplored upper areas of the shaft will tell whether the intended angle is several degrees smaller than that of the southern shaft, or whether both shafts were to be constructed at the same angle that is quasi-symmetrically. Blocks number 2, 3, and 4 all show signs of minor settling. The first 3 joints of the shaft are aligned more or less vertically in order to deflect the weight of the roof beams into the horizontal plane. At the start of block number 7, we see the threaded end of a hexagonal iron rod, which was obviously left behind in the more recent past. As no scholar reports investigating the shaft using such a rod, we can assume it is an artifact of an unsuccessful treasure hunt which was supposed to remain secret. In 1872, Wayneman Dixon found and chiseled open the lower ends of the shafts, which had been invisible until then. In his diary and in unpublished letters to Piazzi Smith, which was the Royal Observatory Edinburgh, are in the Royal Observatory Edinburgh archives, Dixon places great importance on the lower shafts and mentions that he was on the verge of a great discovery. After that, the shafts received no further attention except for angle measurements carried out by Petrie. We can thus assume with some assurance that the iron rod was left behind by Dixon. So he was shoving an iron rod up there thinking that he might knock something loose.
Yeah.
Each section of the hexagonal iron rods measured 2.7 meters in length and is fitted with a round socket which allows it to be jointed to the next section. Right, so you can screw in the next section and shove it in farther and screw in the next section. In one of the lower shafts, Dixon found 3 objects. So when he breaks it open, 3 things came tumbling out. 1, a copper grappling hook, quote unquote, grappling hook, about 5 centimeters long. 2, a small gray-green stone ball. And 3, a broken off piece of square wooden slat or rod about 13 centimeters long. This is the copper hook that came out.
Huh. Okay. Could have been a seal
part
holder.
Part of the hooks. Yeah.
Seal holder. Eh.
Unfortunately, in his writings, Dixon doesn't say in which of the 2 lower shafts he actually found these objects, but he mentions them in connection with the northern one. Except for the stone ball, the objects are broken fragments. Thus, I assume that Dixon didn't simply find them lying in the horizontal segment of the shaft. Instead, I think that by jabbing the long iron rod into the shaft, he broke the objects off or something, which then slid down to the bottom. This assumption is further supported by finds made at the bend in the shaft described in detail below. The grappling hook and the ball are now to be found in the British Museum at London. The fragment of wooden slat no longer exists.
So, I mean, like you were saying, as you build up and they're blocked off at the bottom, anything that falls in there
is going to be stuck in there.
Yeah, and then it's going to hit that. It's going to hit that last bend, or depending on where you drop it, it's going to hit a bend and perhaps get stuck.
Yeah. So if you dropped your diorite hammerstone, and it just rolled down in there, and you're like, well, I'm not going to tell anybody about that.
Johnson, where's your hammerstone? Oh. God dang it. Go down and get your hammerstone. He's got gone for 3 hours. Trying to find a new one.
Queen's chamber.
He needs a new one, right? He's like, oh, I got to go.
Yeah.
Can I borrow your hammerstone? No,
I got to run
Johnson.
out to the quarry and get a hammerstone. The west wall of the shaft at about the middle of block number 8 displays a strange, broad, black streak reaching from floor to ceiling. The streak is partially interrupted by gouges, most perpendicular to the streak, left by a chipping chisel. We made an almost identical find at the beginning of block number 9, also on the west wall. In this case, the streak is not broad, however, instead is made up of 2 parallel lines. It is also interrupted by traces of a chipping chisel, but it is obvious here the chiseling was done only over the 2 parallel lines. The find, at least in terms of the indentation or interruption of the lines by chiseling, is reminiscent of the niches in the Great Gallery. Those niches were closed using exactly fitted stones to restore the smooth surface of the walls. Here, too, the intact surface was again destroyed by coarse work with a chipping chisel. So in other words, it looks like a black stain is on the wall of the slab, and somebody tried to use a chisel to get rid of the stain. Not very well in both cases.
Yeah.
But why are there black marks? You know, it's weird. In the second third of block number 9, in between the iron rod and the east wall of the shaft, an accumulation of a dark, unidentified material lies a small rectangular object. The object seems to have 2 holes drilled into it. So it's hard to see, but basically the iron rod that Dixon shoved up in there is bending here, and there's something caught right there that has holes in it between the shaft and the wall.
Yeah.
It may be a bracket of the iron bar itself. It's hard to tell. It kind of looks like a bracket around the bar.
Yeah.
Concerning the grappling hook he found, Wayman Dixon notes in his diary, the thing is bronze green and with strong incrustations agglutinated, or agglutinated, once riveted onto a wooden handle. The grappling hook does indeed have 2 rivets, but we don't know why. Dixon asserts that it had been attached to a wooden handle. It is possible that on the hook he found traces of wood which have since disappeared. So it remains a matter of speculation whether or not the hook was actually connected to a piece of wood, and if so, what it may have looked like. But the space between the rivets and the hook does coincide exactly with the space between the holes in the small rectangular object still in the shaft. So the latter could originally have been attached to the hook.
Probably what happened was Johnson drops his hammerstone into the shaft and then grabs the wooden hook
rod.
handle rod and shoves it down in there to try to get his hammerstone and breaks the hook handle rod.
Yeah. And then that slides down
And then
into the shaft.
he just chunks the leftover piece of wood down in there, and you're like, where's the hook handle? Oh, I don't know.
Yeah. Oh, I don't know, boss. Where's your hammerstone? Not sure.
Dang it, Johnson.
At the end of block number 9, the shaft angles about 45 degrees to the west in order to avoid the static structure of the Great Gallery. It is at this point that Dixon's iron rod, which is bent around that angle, apparently got stuck. Unable to remove it, he seems to have given up this probing of the shaft and then unscrewed the lower section of the rod, which otherwise would have remained protruding from the shaft entrance. Sticking out of the shaft at the point where it angles to the west, a square rod lies on the shaft floor extending to the east wall. Originally, we assumed this was a piece of Dixon's iron rod which had broken off at the bend in the shaft, but even then I was surprised that the square rod lay under the hexagonal rod and not over it, as might originally be expected. At that time, we didn't yet know that in 1872, Dixon had found a piece of square wooden slat or rod, which he noted in his diary. So in other words, his iron rod is going over top of this piece of wood thing in there. So it's holding it stuck to the floor. He noted in his diary, bit of wood broken off from a larger part measuring 5 inches nearby, plus accidental fractured end. Accidentally fractured could only mean that Dixon himself caused the fracture. A supposition additionally supported by the remark broken off from a larger part. Dixon probably continued to jab the iron rod up into the shaft until the reported object slid down to the bottom. In the process, he apparently broke off the end of the wooden rod with the hook. The visible end of the square rod, which our robot discovered, shows clear signs of having been fractured, so it seems most probable that the hook was probably attached to a long, square wooden rod, the remains of which still lay in the shaft.
Yep.
Johnson's hook.
Johnson's stone hammer hook.
Stone hammer hook, yeah, hammerstone hook. In 1993, Upuaut 2 was not yet capable of negotiating the sharp westward bend of the shaft. Nonetheless, the robot's camera provided us an initial view of the continuing shaft. We can see that the end of Dixon's iron rod is rammed into the right wall. The square rod protrudes a long way into the shaft. It goes all the way. It looks like it goes all the way up.
It had to be what it was. Like, I mean, as you're building up, you're going to drop stuff and you're going to try to clean it out.
Yeah.
Get a longer and longer tool as you're, trying to make sure it stays clean, cover it.
Yeah.
And then when the next stone comes, uncover it, put the stone in.
And look, see that? This is his iron rod. It looks like something is on the end of the...
Yeah. Yeah.
So he says, we can see that the end... Okay, the square rod protrudes a long way into the shaft. At its end, there is what seems to be a rectangular structure. Unfortunately, it is so far from the camera that, at this resolution, no further details can be clearly perceived.
So he couldn't get far enough up in there.
He couldn't make that turn. He could get the camera to look around the corner, but his robot couldn't negotiate that angle turn. Only further investigation of this part of the shaft can clarify the situation. So
Today we ought to be able to get up in there easy.
yeah. Okay. The lower southern shaft. This is the one where we found the door. Okay.
I can say in like 100 years or a couple hundred years, they'll have some ridiculous imaging capabilities, and they'll basically scan the shaft, and they'll find all these tiny little quadcopter drones just like crammed up in there from people trying to fly them up in there.
After an initial horizontal section of 1.96 meters penetrating the first block of the Queen's Chamber wall, the shaft inclines at an average angle of 39.6078 degrees, which we determined by taking 24 measurements over a distance of 28 meters. Between block number 2 and number 3, we discovered a settling of 3 to 4 centimeters, almost certainly resulting from the pressure exerted by the roof beams of the Queen's Chamber. The lower northern shaft displays a similar settling, although there it is distributed along the course of 3 blocks. The first 3 joints of the shaft are vertical to deflect the pressure of the roof beams into the horizontal plane. Block number 8 has an unusually irregular surface. This riddle is solved by block number 9, one wall and the ceiling of which are rough, but the western wall is relatively smooth and shows signs of having been worked with a chipping chisel. Apparently, the ancient Egyptian builders first initially shaped the shaft blocks with a pointed chisel, explaining the uneven surface, and then dressed them with a chipping chisel. Blocks number 8 and 9 were evidently built into the structure in unfinished form. So, like, you can see the shaft walls are very rough.
Yeah.
Like somebody didn't smooth them out. Johnson didn't get in there with his belt sander.
I'd like to see a belt sander that can do that job.
Blocks number 16 and 17 are offset by about 3 to 4 centimeters. It is impossible to determine with any certainty whether this deviation occurred during original construction or at a later date. This spot lies just under the floor level of the King's Chamber, where Petrie discovered unusual settling. Right, so they're settling in the floor. It is possible that this settling and the observed deviations were caused by an earthquake during the pyramid's construction. Ooh, that would have sucked.
Yeah.
From block number 19 onwards, we detected strange scratches on the walls of the shaft, extending all the way up to block number 26. Depending on the surface texture of the walls, these scratches appear with varying clarity at a consistent height of 2 to 3 centimeters above the shaft floor. See them?
Yep.
The scratches are not very deep and are visible only because they penetrate the stone's patina. Since the scratches extend over the block joints, it is obvious that they were made after the shaft sequence was finished. It would appear that something was dragged up through the shaft subsequent to its completion. Shortly after the joint leading to block number 21, a bit of light-colored mortar, most likely gypsum, adhering to the west wall of the shaft gives the impression that here something was originally attached to the wall. See, I find all this stuff fascinating. Like,
Yeah.
There's so much more inside these shafts than just the fucking door. Dang it.
Yeah.
You know, I'm like, all this stuff is really important, especially the static stuff that applies other chambers. I think it's really cool. And that they drug something up through the shaft and just things were glued to it, and there's weird black marks that somebody tried to erase, and just like it's straight crazy.
I've never really thought about that though, like the fact that they had to be closed off in that granite.
Yeah.
I mean, you can't build that room without the bottom block.
Right.
You know?
Yeah. Yeah.
And so you're building all the way up knowing that anything that goes down there
Is down there.
you're going to have to fish it out or it stays.
Yeah.
So
In 1843, Burckhardt found a similar impression, somewhat larger, on the walls of the Great Gallery. In other words, an impression of something stuck there with gypsum, some glue. He established that it was made of mortar, which in a long, round object had originally been embedded and later removed. He could not determine what that object may have been, but he assumed that it would have been attached to the gallery wall by means of the mortar. We made an identical find farther along the shaft at block number 26. Just as with block number 21, the impression here is located on the west wall of the shaft at the beginning of the block. There it is. See, something was glued there.
Yep.
There may be a connection between these hollow impressions and the scratches. It is quite possible that the mortar was used to temporarily fasten strings to the shaft wall. These strings could have been removed later by giving them a sharp tug, causing the mortar to break away and leaving behind the kind of hollow impression of the strings that we observe today.
Huh. Why would they do that?
Like, in other words, the scratches...
measuring it or something?
In other words, the scratch... I don't know why they would have done it. Yeah.
They, like they're leaving... Okay, here we go. Practical application. So you get so far up and you've dropped so many things that you've spent so much time fishing out that you're like, all right, let's build a little wall.
A little net, maybe, or a wall.
Yeah, a little wall inside there, and we'll attach this thing to where whatever we drop over the next so many courses, we'll be able to drag it all out with this. So if we drop a tool, we don't have to worry about it. We just keep building. Yeah. Once we get up so many levels to the end of our string, we just pull the whole thing out.
Yeah.
All the tools come out, and then we make another one.
Yeah, that's possible. Yeah. It's a good idea. Okay, at the beginning of block number 26, a large section of the floor has been broken away. This is the worst damage we observed anywhere in the shaft sequences so far investigated. At this point, however, the pressure on the shaft amounts to only 1/3 of the maximum value. Near the Queen's Chamber, 115 meters of pyramid material pressed downwards on the shaft, but only 35 meters of material pressed downwards on this spot where we observed the greatest shaft damage. This highly unusual finding can have resulted only from one of two possible causes. Extremely inept construction work below block 25 and 26. It must be remembered, however, that this is the final section of the shaft which otherwise displays the highest quality workmanship observed anywhere in the shaft system. Or two, the existence of an as yet undiscovered structure below or above this shaft section. Such a structure could produce a pressure peak which it could in turn focus considerable additional force on the shaft and possibly cause the observed damage. Okay. In other words, what he's talking about is that place where the robot encountered the step that he called a tank trap.
Yeah.
The floor is actually cracked off and broken off the lower. The lower block is damaged. So you can see the floor it's actually been fractured upward and you see what I'm saying?
Yeah.
It's the floor that's damaged, not the rest of the ceiling or whatever. The block up there, it isn't shifted up. This one isn't shifted down. The floor is broken.
Huh.
And you can see how it's like it just split, cracked, or whatever. At block number 26, the shaft floor is marked by a long cutting groove. We found more such grooves in the floors of blocks number 27 and 28. There's a groove right there. Such grooves were caused during the construction of precise joints. Two blocks, which had been preliminary worked with a chipping chisel, were shoved together. Then a saw was run down through the gap remaining between the two blocks, removing material from the ends of both. This procedure created a precise joint between two adjoining blocks. This method also leaves behind a cutting groove on the block underneath, a fact which testifies to the use of this method. In other words, they cut past and made a groove in the floor. Based on the grooves found in the shaft, we can assume that before their insertion as floor slabs, these blocks served as the base of cutting of precision joints. So somebody was using them as as like sawhorses.
Yeah, just like you stack wood on top and cut the top piece of wood.
Yeah,
and then you end up using the bottom piece and it's got little grooves in it.
Yeah. This gives rise to a crucial question: exactly which precision joints were cut here? The shaft blocks themselves were only dressed with the chisel. We observed ample evidence of this in the Caviglia tunnel on the lower sides of the shaft blocks, as well as at several sites of block displacement, which exposed the abutting edges. At the upper southern shaft outlet, both outer sides of the blocks were visible. These too were worked only with the chisel. Thus, as 9 of a total of 10 surfaces of a shaft block were definitely chiseled, we can well assume that the shafts were constructed without recourse to sawing. The pyramid's nearest casing stones, which lie 19 meters distant from this spot in the shaft, were cut in their final position. We know this because the stones located directly beneath the casing stones displayed the cutting grooves.
Oh, man.
The pyramid's corridor and chamber system, which also displays precise cut joints, had been completed long before this shaft construction level was reached. Right? So if the casing stones, which were precisely cut with saws, were cut in place, and we could see that because of the grooves on the blocks that they were sitting on, and all the chambers that had the other precision cuts were already finished at this point, what precision blocks were being cut on these blocks? For what chamber? That's the question.
That's freaking awesome. Because they're above all the known chambers.
Right, exactly.
Dude, that's a great question.
Taken together, these findings constitute a compelling case for a possible as yet undiscovered structure for which precision joints were made in this upper region of the southern Queen's Chamber shaft. Block number 27 is partially polished. Block number 28 is extremely well crafted, smoothly polished, and consists of a lighter colored material than that of the other blocks. In some spots, including the ceiling just before the mysterious closure stone, very fine, dark gray veins are visible in the stone, evidence of the material's high degree of homogeneity. The veins cross one another, proving that they are not simply fissures. It is physically impossible for static fissures in stone to run crisscross. At the end of block number 28, the shaft is closed by an unusual, smoothly polished stone. This is the door. Protruding from two holes drilled in the stone are bent, slightly conical copper fittings. The openings of the drill holes contain a black, tarry mass. The left fitting is broken off about halfway up. The broken piece slid down the shaft to the end of block number 27, where it still lies, and he has a picture of it. The piece of copper fitting still on the floor.
Holy shit.
Both fittings display round white impressions which have discolored both the stone and the fittings themselves. The impressions were evidently left by a gypsum-like material which has since broken off. So he's got a picture. You can see the... And it's got some stuck to it still.
So the gypsum is just like a mortar.
Yeah.
Okay, so what I had imagined before when we were discussing the seals was like a hole was bored into the stone and this gypsum seal was pushed into the hole.
Oh, no. Like they had some kind of clay.
Yeah.
They stuck it on the block. They put the seal symbol onto it, and then they were held in there by the copper thingies is the idea. The copper things were then slid into their holes with the bend down to hold the seal in place, stuck to the rock. Just like the glue.
The gypsum was
like
the
a
glue.
mortar, yeah.
And so the seals are gone.
Yeah, that's right.
So the gypsum is all that's left.
Right.
Okay. All right. I got a clearer picture now.
Between the closure stone and the shaft floor is a gap of 5 to 7 millimeters, which we determined by comparison with the diameter of Upuaut's laser beam. Thus, the visible lower edge of the stone does not lie totally flush with the floor. Close examination of the broken lower right corner shows that it is held in place by a groove or recess.
Yeah.
And at this point, the stone is only about 5 millimeters wider than the shaft itself. The surfaces of the shaft blocks which lie on the floor have chamfered edges. Thus, in the video wide shots, the lower left corner of the stone is also visible. Here, too, the stone is only slightly wider than the shaft. The lack of a shadow at the upper edge of the stone indicates that it is taller than the shaft itself. But there is no way of establishing how far the stone extends into the ceiling. Right?
So they're talking about the door stone.
Yeah. Since it just appears to merge seamlessly with the ceiling, they assume that the ceiling is below the top of the block of the door. In other words, the door is laying on the edge of the shaft block. And there's just no visible shadow cast by the light from the camera.
Right.
No traces of mortar are visible in the closure stone. This is unusual as the joints of most shaft blocks do show such traces. We were able to recover bits of white gypsum mortar from the shaft, indicating that the shaft was indeed laid using such mortar, but the closure stone was apparently mounted with great precision and held in place by grooves or recesses without using mortar. Thus, we may well assume that the stone is, in some way or another, movable.
Yes!
In May of 1993, hoping to supplement our purely visual evaluation of the copper fittings, I asked English metallurgist Hugh Tyrer to examine the relevant video material. Tyrer and his company, HT Consultants, played a key role in the metallurgical aspects of the development of the Concorde aircraft. On the basis of the two-dimensional video images, Tyrer was able to come to several conclusions. 1. The corrosion coloring and the surface texture indicate that the fittings are indeed made of copper or bronze. 2. The extent of the corrosion is quite normal for a period of 4,000 years, given the prevailing level of humidity within the pyramid. And 3. The broken piece of the left fitting and the left fitting itself both display smooth fracture surfaces. Thus, the piece of fitting did not break off due to outright corrosion. The smooth fracture surfaces would indicate that the fittings were made of cold forged material. During the forging process, the material was stretched, causing a very fine crack. The ongoing process of corrosion eventually caused the fitting to break at that fine crack.
Yeah.
Traces of hammering carried out are visible on the left fitting at the point at which it emerges from the stone. This is an indication that the fitting was first pushed through the hole drilled in the stone and then struck with a hammer to bend it downward at a 90-degree angle.
That's freaking awesome, dude.
So that's why I wanted to take time. I know we've gone over, and I know some of that was probably like, it's a lot to get through, but it's incredibly important all the details that are never talked about in the story about the shaft and the door.
Right.
Like, when you really think about it, the door is interesting, but it's not the best evidence of other chambers.
Yeah.
Right? The best evidence of other chambers is in all this other stuff that he was finding, and then the other weird things that are in there. Like, but the static forces and the way the joints are constructed interior of the shafts tells you that stuff is happening outside the shafts in a place where, according to what we know about the pyramid, there are no other structures.
Like when it's going around the Grand Gallery, you're looking at these specific types of joints that make sense because there's static pressures on the stones
and there's a known structure, the Grand Gallery.
Then it goes back to normal for a while, and then you get back to these crazy joints that you saw when it was going around the Grand Gallery.
Right. And you're like, okay.
Oh, dude, that's freaking awesome.
Yeah. So that's it, folks. That is the pyramid shaft door Rudolf Gantenbrink story. It's fascinated me for a long time, and I'll never forget the visual of the of the inspector in the room with him when they finally see the door, and how the guy turns white and freaks out and starts shouting that these are seals and we have to stop everything, and then they get kicked out of the country, basically.
Yeah, and their story was never published.
Right.
So I thought about that for a long time, and the only thing I could come up with that makes any sense is that he knew something.
Right.
Like, that they've all perhaps known, the people, the higher ups.
Right. We talked about how they might have been warned about, seals of some kind. Like, if you ever see something like this, stop everything.
Right.
Right. Old Kingdom seals or whatever it is that they thought that they were. And there are no seals in there. The guy just saw indications of the presence of seals and flipped out.
Yeah. It's like they've been, the antiquities department or whatever obviously they have knowledge that they haven't published. Like, this is proof. They didn't publish the findings,
for 10 years or something like that. Yeah.
Right. So they hold information that they know. And so you can imagine that as long as they've been in existence, they've been holding information and not publishing it. And that's what it makes me think of. Like, he saw something that all of them, everybody involved in the higher ups of the antiquities department, had been warned about, been told about, and he's like, oh, we gotta shut down the operation.
Exactly.
That's just,
and I mean, Hawaii started moving members of his team away.
Yeah.
As soon as he started figuring out that they really were finding stuff.
Right.
So.
God.
All right. I appreciate you guys sticking with me on that. I know it was a bunch.
I loved it.
All right, you can get a hold of us at brothersoftheserpent@gmail.com.
Go to the website, brothersoftheserpent.com. Comment there. Check out the encyclopedia. You gotta see the glossary of terms. So
I've been posting those on the Twitter.
Yeah, so you can get the idea of what is Johnson and what is non-Johnson.
That's right. And follow us on Twitter at Snake Bros with no vowels, SNKBRS. I have been posting a bunch there, and we've got a lot of people following us, and the whole great crew there. A lot of whole thing going on Twitter. It's awesome.
Yeah, and it really helps if you really like a show, whatever your favorite show is, try to share it with your friends. It really helps us out. Try to get other people interested.
That's right. And donate to our pyramid scheme by way of PayPal. There is a donate button on the website, brothersoftheserpent.com. You can see it on the front page on the upper right there. Click on that. It's real simple. Send us $1, $1 million, Just send us straight to pyramids.
Yeah, and I have confirmation that it is extremely easy to do that. Like, you can, it's a PayPal.
Yep.
But you can click on it. You can use your PayPal, or you can just use a debit card.
MasterCard,
through
whatever.
PayPal system.
Credit card.
It's real quick. No hassle.
And thanks to all of you who have donated. We really appreciate it very, very much.
Yes, thank you.
Yep. And give us reviews. If you can't donate, or even if you can, give us 5-star reviews everywhere you go.
Yep.
5 stars everywhere. Tell everybody how amazing we are.
Well, you don't have to do that. You can tell everybody that you hate the show, but
5 stars.
Give it 5 stars.
I hate this 5-star show. These guys are totally dumb. 5 stars.
You talk about the certificate of ignorance.
That's right.
These guys don't know anything. 5 stars.
5 stars for how dumb they are. And also, History Shift. You guys, check this dude out. You can follow him on Twitter at History Shift. He's got a YouTube channel. He also has just started a blog to post his various photos. He's been going around in Montana taking pictures of dolmens and other glacial erratics.
Heck yeah.
This guy has been transferring all of our podcasts to YouTube videos with slideshows of the various pictures that we use. It is so awesome. He's basically now running our YouTube channel. He's been uploading the videos and like putting all the keywords in and everything. And the guy is totally awesome. He's been promoting us a lot on YouTube, on Twitter. So follow him at History Shift and check out his YouTube channel too. He has some great stuff there on the on Atlantis and the recat structure, which I did the narration for. And also, I want to give a shout out to a couple of other podcasts. Like, I like to listen to Grimerica. You guys should check that one out. Mysterious Universe is always great if you want the Australian perspective. There's also Mike and Maurice's Mind Escape. Check them out. There's also, if you guys like conspiracies, check out the C Word. They are hilarious, and they explore every freaking crazy conspiracy that you can find on the internet anywhere, and they're hilarious. So check them out. And also, don't forget History Shift. Thank you guys so much. We very much appreciate you and all the promos you guys have been doing for us on Twitter. Thank you so much. And once again, Brandon, History Shift, you are awesome.
Also, want to give a shout out to Kmart with Acoustic Paneling Solutions. He builds acoustic panels for studios, custom builds them to the specs that you want. It's a beautiful design. He uses the acoustic foam panels and makes geometric designs inside a wooden frame. It's a very lightweight construction, so it's shippable anywhere in the U.S. He worked with us and built ours to the golden ratio.
That's right.
2 golden ratio acoustic panels for the Tangent Cube of Science. And they're absolutely beautiful.
Yeah.
A great addition to your podcast studio or whatever you might be doing, music or recording of any type. So check out, well...
Yeah, you could really tell the difference in the room after they were put in. Like,
oh yeah.
It completely changed the sound and made it so much more like a vocal booth.
Yeah, it's great dampening. If you're in a sheetrock room,
yeah.
Those high frequencies are echoing all over the place, and you can, if you have high gain on your microphones, it's picking up that background echo.
Yeah.
You get these acoustic panels. They look beautiful. It's like framed artwork on your wall, but it's helping out your sound quality.
Absolutely.
They're wonderful, and
yes.
thank you Kmart for doing that for us. You guys, if he will build them custom specs.
Custom colors and stain. You can get a hold of him at acousticpanelingsolutions@gmail.com.
That's right.
Kmart. He's awesome.
Heck yeah. Thanks, Kmart.
That's right.
And thanks all of you listeners.
Thanks to all of you listeners. We love you. Good night, Adamu. Find secret doors in pyramids.